It's important to confirm what SQL actually is for obvious reasons. Now, it can actually be a very complex topic to get your head around. The learning curve for actually getting some practical experience with SQLs is low, but even knowing where to start can be problematic because you come across terms like SQL, which is actually just an abbreviated form of the initial terminology for SQL, which translates as structured query language. That name in itself isn't very descriptive as to the purpose it serves and why it's so popular, especially within the data domains. Also, you tend to come across terminology like a MySQL, PostgreSQL, SQL Server, then there's a SQL Server Management Studio, MySQL Workbench. The terminology is so commonly used across different proprietary software, it becomes very complex. So let's try to break it down. So SQL stands for Structured Query Language, as previously said. And in the next point, we'll look at why myself and many others pronounce this as SQL rather than SQL. So in this case, SQL is a standard programming language, and we use that to organize, manipulate, or retrieve live or archived data from a computer database or a database. So essentially, SQL is this programming language that has the ability to extract data as it's held in databases. It also has the ability to create databases and create tables and so on, and we'll look into this too. But it is the gold standard language, basically, to communicate with different databases. And databases are really important, and now more so than ever, because if we look at say, for as an example, someone like Facebook from a very broad perspective, the or any social media company, you start off with the architecture where there's a proprietary platform. That would be Facebook, that would be the application. But every day, there's millions of users who go ahead and input their data, they sign up, they interact with various different parts of the application, they maybe sign up for bolt-ons or links to different areas within the application. Now, how do you track that? How do you track how many people are, leaving the site? They're deleting their accounts, they're setting up accounts, why they've set up accounts, which platform they came through. So the front end application isn't enough. There needs to be a way to retain all of the data, the user preferences. And a lot of this also comes into understanding who's signing up, why they're signing up, what demographic they're from. And this will contribute to the business improving because they have insights to these metrics and they can begin to capitalize on the strengths and improve weaknesses. So there needs to be some way to hold that data. So this is where technology like SQL comes in, because a pipeline will be built, which is just a conduit for transporting data into something like a data warehouse or several databases. So there may be a database dedicated to all the user details within Facebook. Now, then people go in and we want to get insights from this data. Well, we want to query it in structured query language. This is SQL, is how we communicate and extract that insights from the database. And that's how we eventually shape this and get it ready to import it into a business intelligence tool potentially, like Power BI, or maybe people just want the SQL result outputs, and we can also provide that. So it takes people like us who are proficient in SQL to actually go in and get insights about Facebook, to understand the people who are signing up. And then we use that to communicate with the business. We use our technical skills in order to provide the business insights and improve the way they work. Now, this is an interesting piece because this is why data professionals aren't necessarily uh, data isn't an IT discipline, although it's highly technical. There's programming languages and software, still forms under a business domain because we directly improve the business with our insights. So that's why SQL is really valuable because we can communicate with all this data, but we need this standard language to do that. So we need our SQL. We need to know the language. We need to be proficient with it, and it's really just fundamental in anything we do as data professionals. So I say SQL, and most people do, because the original name when this was formed by IBM way back over 50 years ago by Dr. Edgar Codd was Structured English Query Language. So it gets abbreviated to SQL. And that's why we have the pronunciation of SQL. You will hear people say SQL, but it's not as popular. It's also been an international standard since 1987. So it shows how long it's been recognized as a really integral part of programming, databases, computing, and now becoming more within the business industry. Because there's a lot of different dialects and companies, we'll focus on SQL Server, which is Microsoft's version of SQL. That's their dialect, and we use that as what we call a relational database management system. There are other alternatives you may have seen, such as MySQL, such as PostgreSQL, such as IBM DB2, such as Oracle, but we'll focus on SQL Server, and there's a number of reasons for that. First, a lot of companies work within a Microsoft architecture. You have 365, you have Word, you have Excel, you have PowerPoint, you have Power BI, and it's a logical extension to stick to that architecture. SQL Server is very popular. Um, but what's important to know, like I said, it's an ISO, it's a standard. There's ANSI standards as well. So essentially, if you learn SQL in any dialect, you really have 80% to 90% of the knowledge to work in any other SQL dialect. So it's not a big deal. And SQL Server's got it's very recognizable and popular, so it's a great place to learn our SQL fundamentals. If you want to dive a bit more into the theory, SQL is built upon relational algebra and set theory. So, although the learning curve to get started isn't really that complex, when you get into the really sort of in depth nature, it becomes a really powerful but deep element of computer science and programming. So it's based upon set theory, which is the mathematical study of sets or collections of objects. So there's a slight learning curve, and we gradually build on it, and it's really good to pick up. But it has the potential to be quite complex, and a lot of that complexity arises when you have complex business logic. So that's the reason, and we have to translate that to a technical skill set, and in this case, SQL. That's the reason I'm going to try and keep rejigging your mind of the business scenarios behind what we're actually learning or doing. But there's a lot of information to take in initially, but we're going to move into practical examples very soon. That's the best way to learn and cement the knowledge. So please don't be put off. And once we get started, you'll realize that what seems to be a lot of muddied and almost intimidating terminology isn't, and you're going to discover the magic of what's possible, and that's really exciting in itself. So stick around as we go through the sort of last of the theoretical elements, and we'll be diving straight into the practical side. So we went over what SQL is, why we would use SQL, and now what SQL Server is. So put simply, SQL Server is Microsoft's Relational Database Management System, RDBMS. There are many RDBMSs, and that would be things like PostgreSQL, very open source and powerful, common. MySQL, again, a popular option. We would look at things like IBM's DB2 or Oracle. These are all popular RDBMSs. But then it's gotten a bit more complex because we've got SQL. Now we've got these RDBMSs, and it's a bit complex to see how these interact with each other. So let me give you a simple analogy. Essentially, the RDBMS is the warehouse. So SQL Server is Microsoft's warehouse, essentially. It's where we host all of our tables. It's where we go ahead and connect these tables together. It's where we get our insights from our data. So SQL Server is just essentially the storage for all of our relational data. And that would be things like the tables that we query and the databases. And that's fine. And what SQL is then is just the query language that allows us to extract that data. So that's the way that we communicate with the warehouse, which is essentially, like we said, just that collection of tables, databases that are stored within the Microsoft RDBMS SQL Server. And we just use SQL to interact and get that information back. Now, here's where it gets slightly more complex. We're going into the practical elements and we're going to install something called SQL Server Management Studio. But all that actually is the IDE, the editor, the front end, so that we can basically communicate with users. This is the conduit for using our SQL. This front end allows us to use SQL to query our data that's in SQL Server. So like we said, in that warehouse, that tables, the data. So we take that SQL Server where it's hosted all of our data. We use SQL to communicate with it, and we do that all through the medium of something we'll install called SQL Server Management Studio, which is just a nice front end or guided user interface to actually allow us to interact with everything and see how it's being done. Now, the last thing, Microsoft, so SQL Server, has its own variety of SQL called T-SQL or Transact SQL. This doesn't deviate much from just standard SQL. We have something called ANSI standard SQL, which is something that all of the different SQL dialects sort of align with. So like we said, we have different RDBMSs. We could have MySQL, Postgres, Oracle, and SQL Server, and so on. They all have their own slight ways that they differentiate from standard SQL. But like I said, 80 to 90% of the time, what you're learning is just standard SQL. So there's no huge issue there. So again, to just reflect on the sort of architecture, we will be using SQL Server. Microsoft's RDBMS, we can just think of this as the warehouses where everything is stored, all of our data, databases, tables. We will then use SQL. That's like the almost the filing system, how we interact with that data and organize it. And we'll be using Microsoft's version T-SQL. And we'll all do this within the guided user interface that's known as SQL Server Management Studio, SSMS. Now, that's what we're going to use, and it's a standard way to do it. That's how we can easily connect to SQL Server through SSMS. But there are other ways you could use your SQL Server and connect to things like VS Code if you've used that IDE, but it's sort of out with, and it's what we're doing, and it's a bit unnecessary. SQL Server Management Studio gives us that full, rich experience to use our SQL or T-SQL, and basically what is standard SQL to communicate with our tables and data. So a few more, now that we know what SQL Server is, why have we chosen that? Well, we've learned Power BI, we've learned Excel, and a lot of companies who use these tools like to stick to Microsoft. And that's why SQL Server is hugely popular when we're picking some sort of SQL RDBMS, because a lot of companies have a huge enterprise structure that's just reliant on Microsoft. You have Microsoft 365, that could be Word, that could be PowerPoint, that could be Teams, that could be, SharePoint. And all of these things, it just makes sense to stick with a Microsoft architecture for a number of reasons, for pricing and for integration. SQL Server also is fast, it's good, it's a simple installation, it's got good security. So they're all the points in SQL Server's favor, and it's just really well known. We spoke before about legacy systems. There would be a lot of legacy systems built on SQL Server. It's also very scalable because now we have something called Azure SQL, which is what we would call in the cloud. Everything can be done through a web browser interface. But we can actually connect that all through SQL Server Management Studio. So by learning everything that we have here, not only does it give you insight into the way things are currently being done in the industry, I'm also giving you a glimpse into how you can sort of scale up for the future. So that's SQL Server. That's what we're going to be working with as we move into the practical elements. So this should give you an insight into why we're doing the things that we're going to be essentially installing or, starting to learn. So it's important to note that this will be a gentle learning curve, and SQL, the great thing is it's essentially like Lego blocks. We build a bit of the foundation, and that certain element that we learn, we build a bit on top of that. And you could say that about any learning, but it will become apparent in SQL. We've got a lot of clauses and statements and functions, but we always use them. We just use them in a slightly longer or more complex way when we get a bit more intermediate or advanced. So this will all start to make sense, but I need to give you the groundwork and the foundations because I don't want the terminology to get too overwhelming. So if I can gloss over this, that will be really helpful as we move forward into the next practical elements. In the second block, we're actually going to look at getting started with SQL Server. So we've looked at some theory, and in the next sections, we're actually going to look at real functionality, practice demos, building things. But in this particular section here, we're going to actually look at importing and downloading SQL Server and SQL Server Management Studio, where SQL Server is Microsoft's extension of SQL, how we will communicate with the database. SQL Server Management Studio being the front end, the IDE, that's how we actually visually connect and query those tables and databases and create things. Now, then we'll go on and we will actually look at, we've downloaded SQL Server and SQL Server Management Studio. We'll then go ahead and look at importing in the AdventureWorks database. So this is a sample database provided by Microsoft that details a fictional bike manufacturing company, bicycle manufacturing. And we've actually used this, if you were in the Power BI block, you've actually used this here. So there's a circularity in the data set. So a lot of what you see may actually be familiar, and that might be quite helpful. From there, we'll actually go in and just look at how to navigate on a basic level SQL Server Management Studio. Again, this is the front end and how we're going to use our SQL Server skills to extract and model and manipulate data from our sample databases. So this is going to be sort of give us every step to get started. The great thing about SQL and SQL Server is it's all free. There's no need to go through enterprise licensing or go through free trials. Everything's free at your disposal, and this is going to allow you to refine and practice as much as you like, probably the most fundamental skill that a data professional can have. Now we're actually going to install both SQL Server and SQL Server Management Studio. So we're at microsoft.com, ENUS, SQL Server downloads. Obviously, it may be different in your region, but you can just Google SQL Server download and that will take you to the page that you see here. Now, we're first going to install SQL Server, which is our RDBMS. We need this to write SQL and interact with databases. We can actually get a free specialized edition to get the full experience. We can actually download the free developer edition. So we'll go ahead and do that. Click there. And this is basically going to install an executable file, which we need to click on with open file. And this will take us through the download and installation process for SQL Server. Now, this video is going to be twofold in that we're going to install SQL Server and SQL Server Management Studio, which is sort of just the front end or the guided user interface for writing our SQL. We can select basic installation type. That will give us everything that we require to use SQL Server to a good standard, so there's no issues there. You can specify where you want to install it. Make a note of this if you like, because that's where it will live. So in our case, in the standard C drive program files. It will take a few minutes to download and install SQL Server Development Edition. I'm obviously going to speed through this. and as you can see, it installs fine after around a few minutes. Now, the next thing that we need to do, you'll see here, there's an option at the bottom to install SSMS. This means install SQL Server Management Studio. We want to do that. Like I said, that's the way that we actually write our SQL code for SQL Server, and we interact with the databases, and essentially for this course, learn SQL in a practical way. So we can download SQL Server Management Studio. That link just takes us to this web page, and you can scroll down, and there will be an option to just for the free download of SQL Server Management Studio. There are some additional details here if we scroll down, but essentially that's what we want to. That's where we want to end up. We want to click on that link. We do see a list of available languages. Obviously, I'll be using the English uh, language there, but you can actually just click free download for SQL Server Management Studio, and that will ensure that you're running off the same version as me. Although SQL Server Management Studio hasn't changed much at all in some time, so there's no real issues there if you do have an existing installation. So again, we get the executable. We just have to click install. We can select where we install the Management Studio, but for me, I'll just go ahead, click install. Obviously, I will speed through this at a slightly faster pace. Again, SQL Server Management Studio usually only takes about a few minutes to install, so there's no issues there. And once we've installed this, I'll just quickly show you what it looks like. I think there's often confusion because we've got SQL Server and SQL Server Management Studio, so it's just important to differentiate between the two, where SQL Server is essentially how we interact with databases using Microsoft's technology and standard SQL, and SQL Server Management Studio is essentially just where everything is stored. It gives us the nice front end. We can interact with things, but we could use other what we call IDEs or code editors. We could use Visual Studio, but SQL Server Management Studio is a really nice, fully fledged GUI. So we'll close that down, and we can just navigate to we see installation complete successfully. We can navigate to our um, just the home screen of our laptop or PC Windows machine. And in your taskbar, instead of navigating to your files, you can just type SSMS, and in a couple of seconds, it will load up with SQL Server Management Studio. From now on, we don't have to worry about any program with SQL Server because we just use SQL Server Management Studio. So this again will just take about a minute to load up, but if you see that screen, you know that things are happening. Usually the black screen will fade away, and then we'll be able to log in. If you just log in as I am locally, just with your desktop name as a server, that's absolutely fine. And this is what we'll be working with. So obviously we're going to get much more accustomed to this, but this is how SQL Server Management Studio looks. At first, it looks a lot more intimidating than it actually is. So stick with me and we'll learn a lot practically. We're going to look at importing and downloading the AdventureWorks sample database into SQL Server so that we actually have something to query, and not only have just some data to query. It's actually very extensive with over 50 tables, I think around 70 tables of data, both in a fact or transactional and a dimensional format. So we can do anything we require within SQL. So through learn.microsoft.com, there is links to download the relevant AdventureWorks sample. What we can assume is that if we're running one of the newer versions of SQL Server, we can likely just use this backup file at the top here, which would be AdventureWorks 2019.bak. It's a special type of file that we can use to almost point our system towards it, restore it, and we get this sample file available within our SQL Server. So that will download fairly quickly, usually about a minute or two, and we have that available. But now we need to understand how we take this file and bring it into the correct location so that we can point SQL Server to it. So from within our file explorer, it'll be in the downloads. You need to I would select to cut this file because we're going to paste it in the correct location. So in most cases, this would be in this PC, in your local drive, so your C drive, your local disk. And from here, you want to go into program files, and you will want to navigate down to Microsoft SQL Server there. And from there, you will have this option. It'll look like this, MS SQL 16. It may be slightly different depending on your version, but it will follow that general format. You will then have a subfolder within there, MS SQL, and then you will have backup there at the very top, that folder, and it's empty. That's good, that's fine. You just want to paste in that file that we previously selected to cut. So much like copy paste, but cut will actually extract it from its previous locations. And it's now housed fine within the backups, and that's where we want to be, because now we're going to point SQL Server towards it. So with that, we can get rid of the File Explorer and now just focus on SQL Server Management Studio, which is our interface for SQL and using SQL to query data and create data within Microsoft. That's just Microsoft's version of SQL Server. So now we can go to our database, and we want to hit Restore Database within the Databases folder within the tree structure. So from here, it looks a bit intimidating. There's a lot of options. As long as you remember to hit Device to select that checkbox, that circle there, that's directly under Database, then we can go in and actually select our backup file. So we can hit that ellipsis. There's nothing in the drop down correctly because we haven't pointed it to anything. So we hit that ellipsis, 3 dots, click that, and we'll get backup media type. File is fine. We just need to add. So when we click on add, it should just point us directly to the backup file, because I'm trusting that you probably don't have a lot of these files, the .bak extension hanging around. So we'll select AdventureWorks, and that will go ahead. We can click OK, and AdventureWorks is great. There's about 70 tables, I think, based on sort of mock cycle manufacturing. So there's a load of dimensional data around people, around production, lots of schemas, which is just collection of data objects. So it's really good and comprehensive. You can pretty much build any project with it. Just scroll through the options, everything looks fine. So all we actually need to do from here is click OK. It will take a few seconds usually. And it says it's restored, which means we now have this available. What we should do is refresh our databases folder here. So you can right click, scroll down, just hit refresh. That will do it for you. What you can do if you want to be extra safe, you can just refresh at the Object Explorer level here at the top above our database tree structure. Now when we expand, we see that we now have AdventureWorks 2019. And the core area we'll look at initially is tables, just to make sure we've got everything that we require, and all those tables have actually been populated with data. There hasn't been an error there. So when we expand that, we'll see a lot of tables. Like I said, there's different schemas such as DBO, human resources, person, but this is just how we're logically grouping our tables. An address is related to a person essentially. So we can select top 1000 rows, just query the data within the GUI just to make sure everything's present. So we'll right click, select that, and there we go. We will have our SQL will print off the script that it uses, and we have our data here. So address and so on, lots of data specifically around the people that interact with our business. So I just want to give a short tour of how to navigate SQL Server Management Studio. At first, it may look a lot more intimidating than it actually is, but I'm going to show you the very basics here. And as we get used to running SQL Server Management Studio through our practical examples, a lot of this will become clearer, so don't worry too much. But the first thing to note, I guess, at the very highest level is that the interface is quite like a lot of Microsoft interfaces you may have used before. So if things are looking a bit intimidating, you can take solace in that. For example, we have a file menu to open. We can save SQL files. They're .sql extensions, and we can load them back into SQL if we want to play around with them later. We've got things like editing for find and replace, our views. So the Object Explorer is this pane down here. Bookmarking windows. A lot of these things we'll get to in due course. Refresh obviously being quite important. Project tools here. When we get into things like performance tuning, this can be quite helpful, which is really quite an advanced concept. But we've got things like SQL Server Profiler, which can help us with our performance, and lots of different sort of customizable options here. In the window, this specifies essentially how the area that we write our queries in looks, so we can choose to hide things and so on. But the important part here is within this Object Explorer. This essentially gives us a top-down view of our whole structure in SQL Management Studio, SQL Server Management Studio. So we start off with our server, which locally is just on the database on the desktop here. So we can, again, choose very simply to drag out however wide we want this Object Explorer to be. And if we expand by pressing the plus icon, we've then got all of our other, next in the level of the hierarchy, all our other objects. So we've got our databases, security, server objects, and so on. What we're primarily interested in is this databases section here. So that will expand. It may just take a slight bit of time. And here we have our system databases, but what we're actually interested in is the one that we've imported, which is AdventureWorks 2019. This is just a sample that I created. And when we go down a level and we actually expand or open up one of our databases, we'll then get the option to view all of the associated tables and so on within there. And that's the core of what you'll be looking at. We don't need to worry about database diagrams. They are a feature which may also be noted as an entity relationship diagram, which just shows how things connect, or tables, how they're connected, which keys connect to each other, the cardinality. So if you followed in Power BI, a one-to-one, a one-to-many relationship, a many-to-many, and so on, so that we can reference that when we're joining tables. But we won't be making use of database diagrams. They're by no means an essential. Then we have the tables, which is the all-important section here. And we'll have a lot of tables available through the AdventureWorks database, because I believe there's around 70 tables that we've imported in through our backup file. And you'll notice that they're all sort of, they have a schema in front of them, which is just a way that we can collect and organize similar tables. So for example, department relates to human resources, employee, job candidate, and we just group things like that. The person details, the actual table is really just department, employee, and so on. So this is all of our tables. DBO just stands for database object. That's just a standard schema grouping. And schemas are good because you can govern them centrally with things like security. So again, if we were to take another, we can actually expand down a level in the table and we can get a list of all the available columns. So here we've got department, name, group name, modified date, keys, which is how the tables connect each other essentially, constraints, where we decide how rigid we want to be with the level of information that actually enters our tables. And when we go further down, we've got a list of a lot of tables. We also have things like views that we'll cover later, which is just a way for us to potentially write a query that does a lot of things and save that view for later for querying it. And other elements like programmability, where we'll eventually look into stored procedures as one example, which is a script for performing multiple actions. Now that's what we'll need to focus on straight away. So that's really all I want to get to in this how to navigate SQL Server Management Studio. We can actually right click here and select the top 1000 rows in a table, and this will write a query to our new query window that we see here, new query, and then it will just print out the results. So we'll see we get all of the associated results for this query. We get the address ID, the line, the city, the state, province, postal code, globally unique identifier for each row, the modified date, and so on. We could also close this and we could hit new query. And here's your first bit of SQL. We could say select all which means just select all the columns. Select star means select all the columns and rows from person dot address, colon at the end, statement terminator, to show that we're finished with that if we're logging multiple statements within one script. And again, that would also select everything. Also handy down here to tell you how many rows have been returned. And that is about all we need to know right now to get started with SQL Server Management Studio. We can just collapse everything again, ready for expanding it later. And that's a very top level view in SQL Server Management Studio again. So it's actually quite easy to get started. Looks intimidating at first, but we're going to pick up a lot of snippets as we go through practical examples. In this section, we're going to cover the fundamentals of SQL, but we're actually going to go much beyond that in this block. We're going to look at the basics of SQL, and then we're going to go right through to the intermediate area as well, all within this SQL fundamental block here. Now, we're going to cover a lot, but we're going to start at the very basics so there's not too steep of a learning curve, and then we will gradually build on top of each concept like Lego blocks. So the initial areas that we're going to cover focus on looking at things like selecting data from a table and a database, and then we'll quickly move on to other things like text functions, joining data together. We'll look at conditional logic, filtering, commenting our queries, aggregations, mathematical operators and functions, grouping our data, joining it, subqueries, and so much more just in this fundamentals piece alone. So if you were to cement this knowledge and master everything in this fundamentals alone, you would have enough knowledge to do a lot of tasks within any data department. So what I would encourage as we go through this to just think about applying this to real world situations. I will try and jog your memory at the time and then go away, play around with some of these contexts. We've got a large sample database, and really you need to cement the knowledge by continually performing the functions in different situations. So if you follow along, apply the concepts that you learn here, you will have enough knowledge here to really already be quite powerful with SQL and SQL Server. In this tutorial, we're going to look at the SQL select statement, the very first step on our path towards SQL mastery. Now, before we do that, and I go in and explain things, we'll look at SQL Server Management Studio and just the general structure of it. So we have the AdventureWorks database that we installed. That's where we'll be doing most of our work. And we have some tables available. It falls under a tree structure, so you just keep expanding, and it's from a high level to a lower level. We've got our database, our tables, our views, our programmability, all of which we will learn about in time. But the select statement is essentially just used to select data from a database. And then the data returned is stored in a result table called the result set, and that's what we see as our query output. So first of all, we don't actually have to reference a table. We could simply type select 1, 2, 3, and we would get the result in the result set. Obviously, it's not the most insightful, but it's important to show you what select actually does. And it's really the most fundamental thing in SQL querying, because you can't really do much without the select statement, and you really can't do much of value or of great insight or impact without a select statement. We could also print out hello world into a result set. Just by, as it's text, we'd have to encase it in single quotation marks, but we could also do that. And then the real value comes when we start to reference tables and pull data out of tables. So we will just get rid of that initial query window. And what we can do now is actually start to look into our tables. So you'll see that when we expand them, we have a whole lot of tables, and they're just, you'll notice things like contact type is prefaced with person. That's just because similar types of tables get grouped into what we call a schema that we can specify. So everything that seems logical to human resources or production would be sort of, those tables would be grouped together. We can then expand into all the columns that we have. Looks a bit intimidating at first because there's a lot of different data type explanations, constraints like where we can have not null, we can't have null values, keys, primary keys, the key identifiers in a table. But this will all make sense gradually as we move on. So don't get worried about that currently. So let's say we have our production.product table. We can right click and on that and click select top 1000 rows, and that would then display those. The reason it would display the top 1000 is if we have a massive table with millions of rows, it would take a while to load, so we wouldn't want to do that. But then you can see the script that gets printed. It essentially selects all the relevant columns from the table that we specified, and we're able to get this output. So in some ways, it's quite amazing that we can just type select, specify from, and we get all of this data at our fingertips, which most business users wouldn't have access to because they wouldn't have either rights or a working knowledge of SQL. So it gives you a whole other sort of element of power, and also SQL will always be something that's fundamental to increasing your uh, job roles or your value to a company, especially nowadays where data skills are becoming more and more necessary, even outside of specific data roles. So let's actually look at how we can reference the table itself within a select statement. We need two elements here. We need the select statement and we need to specify something after from. So after from, we just specify that table. So we first type it out exactly as it is, the schema object, which is production, and the table, which is product. And we can do this, say, select star, which means basically select all columns from the table. Because we could go ahead and specify specific columns, and that's the best thing to do a lot of the time, to be specific. It keeps your query quite performant because we're only selecting the relevant details. But for now, select all is absolutely fine. It's not a lot of data, and you can see it returns all 504 rows and all columns if we use the select star method, which gives us a lot of data, like I said, some of which isn't all that relevant, but it's important to note that that's how simple it is to go in and actually start to grab data. Like I said, if we want to replace the star with specific columns, we just need to type out those column names. We have something called IntelliSense as well that will automatically suggest columns for the table that we've specified. So we get product ID, maybe we want to look at the name, the product number. You'll notice that the name is in blue because it's actually, name is a reserved keyword. So really, this shouldn't be the name of a column, but Microsoft have given this a name. We'll look at how we can change that afterwards, and we can execute, and now we just get the specific columns that we require. So actually, we're even starting to almost immediately, we can select all the data, and we're already starting to shape it in a basic level, but it's quite eye-opening just as to how easy it is to get started with some of these functions. So we could actually, go ahead and move columns around, just structure it so that things are a bit more readable. We'll just basically align them. It's not going to affect the query output, but it just means that we can read things slightly better, especially when we get into things like aliasing or renaming the column in a query output. This will be beneficial. So there are a couple ways to alias, and this just means giving this column a new name. So we've got name, we can type as, and then specify the new name that we want to see in the query output. So right now we've got name, and when I refresh this, you'll see next to product ID in our output, the column in results is product name. So we've actually successfully managed to rename that potentially troublesome column name because it's a reserved keyword and it's just not best practice to do that. Now, as is the standard way to do this. You'll see it in many other versions of SQL, such as MySQL and Postgres, SQL, Oracle, and so on. You're not confined to anything. If you want to standard type in block capitals with underscores to separate words, you could do that. Or if you just want to type lowercase with an underscore as well, you can do that. You're not confined to any sort of standard way of doing it just because you've aliased a column name. There also is another way to alias columns that's specific to SQL Server, which I actually find more helpful, but and we'll look at that in time. So again, we can just name this however we like and execute it, and we get the relevant um, alias column. I like to type in Pascal case, which means that each word, new word, is denoted by a capital letter. I find that very easy to read, but everyone has their own preferences, and as long as you're standard with your team, uh, or you're consistent with how you normally do things, that's fine. Now, like I said, in SQL Server, we can actually, instead of using as, we can specify the new name, the alias, write an equals to sign, and that will actually give us a new name. Now, personally, I find this more readable because I like to know immediately when I'm reading through long scripts what each column means. I find that if you have the alias after the column definition, if we have something like an unclear item like name, it would take me a few more seconds to get used to what's actually being done here. So it's all down to preference, but I find it easier just to specify the alias before we actually get to the initial column. Now, this actually is only available in Microsoft SQL Server or Azure SQL. So if you are kind of throwing code about between different SQL dialects, you may want to stick to as. But for readability, I think it's great. And this is just goes to show how easy it is to get started with SQL. We're already shaping our data, we're renaming columns, and we're getting some great insights. So stick with me, and we're going to discover a whole new world of really powerful tools that we can use. So now we're going to follow on from this select statement, but what we actually want to do is we want to go ahead and query data, but only unique values or distinct values. So in order to do that, we can use the select distinct statement. So you can see here where we've selected all from the production.transaction history, we have 113,000 rows. Now, I can guarantee that in this instance, a lot of them are not unique. So there's a lot of sort of duplicated values here for various reasons, and that'd be because it's transactional data would be a core component of that. So if we go ahead and just select the product ID column from the production.transaction history table, we can see that we've got a lot of duplicated product IDs because as we process through transactions, there would be multiple transactions for each product ID. So we can compare that to the original query that we ran, and we can see that in each we have about 113,000 rows. So how do we actually just grab the unique values there? Again, 113,000 rows. So that's important to note for what we'll do next. So we've actually got the select distinct statement, and the syntax is very simple. So we can go down into a new line, and instead of just select product ID, we could say select count of product ID, and that would also introduce us to another aggregation function, but it would also let us know how many rows we have. And that aligns with the value when we queried the initial table. So what could we do now? We could actually go ahead and we could give this an alias, which means that we just give the column, the result output column, a different name, and we'll call this product ID count. And again, building steps that rectifies so that we can see how many rows that we have, even with sort of duplicated values that aren't unique. Like we can see when we scroll down, we have a huge array of duplicated product IDs. So this is the issue, and this is the issue you'll face a lot of the time when you're selecting data, especially from a more fact-based or transactional-based table. You'll need to get a point where you just need to take unique values. Unfortunately, SQL provides us a very simple way to do this. So we can take a new line and we can simply type out select distinct, and then we just need to specify the column, or it could be all rows where we sort of eradicate distinct values, but in this case we want just the distinct product IDs, and we'll just copy and paste that table down from production.transaction history. We'll just need to get rid of that duplicated from because we copy and pasted, so we got two froms. There we go, and that should be good to run. So we can look at what happens if we execute this now. What's important to note, you'll see there we have 441 rows, so that shows just the extent of how much duplication there is in a transactional database. But now we actually only get the unique values for our product ID. Now, if we want to count the distinct values, so before we just use count product ID, the syntax may not be exactly as you expect if you just want to count distinct values. Instead of saying select distinct count, you'll need to select count, and in the parenthesis of this aggregation function where you specify the column, which would be product ID, we can add distinct within that parenthesis before the column name, and then this will give us the count of the distinct or unique product IDs. So we can also type in unique product ID just as the alias again. We can add count if we like, just with the equals operator to ensure that we're providing a suitable alias. And as you can see, as when we queried it and we saw 441 rows in the table result, that is also present when we again query and look for a distinct count of our values. So distinct and select distinct is a really important concept and one to get our heads around early, especially if our data isn't actually organized in such a structured dimensional model. Maybe we have several fact type tables, transactional tables, and we need to work with these, cleanse them, and get to the bottom of them. Then select distinct will be a very good tool within your data toolbox. So previously, we've started to piece together the foundations of querying in SQL. So we would call that DML, which means Data Manipulation Language. And it really is the foundation to everything that we're going to do. Um, and then we'll build from there into some more complex topics. But let's look at our database again. We've got AdventureWorks 2019, which we've installed. Now, what we're going to look at here is the production schema, again, just a way to logically group uh, different tables together. And we're going to look at product. So if I open up my query, new query, we can say select all from production dot product. Now, got my statement terminator. Here's something to notice. The red line denotes an error. And this is something I'm going to show you because you may come across this, and we get invalid object name production.product. So it's saying that data object within this context is throwing an error. So if I tried to execute that now, we would get invalid object name. Well, that's because in here, we're still in the master database. So there's two ways to get around that. You can actually use the guided user interface, simply switch to AdventureWorks 2019, and that would display a result. What we could do is I could take this into the master database again, execute, we're going to have that error, and then I could actually say use AdventureWorks. That would mean whenever we write the query, we're absolutely sure. I'll give it a bit of spacing just to make things more readable. That's very important when you get into large SQL scripts. But this will ensure every time we run the query, it's just in the correct context, and there won't be issues when we run our query. So we've essentially looked at how we can extract data. So here we're just selecting all the available columns. We could use column names specifically and a list of those. And we're saying from where we want to extract this data from. Now that's good, and that's a nice insight into the fundamentals. But one of the key things that we need to do when we're extracting this data is shape it somehow. Now, one of the most critical or core ways to shape our data is using the where clause. So it goes something like this. We have select all from the table we're taking the data from, and we say where. That doesn't look incredibly insightful, it's not intuitive, but once you know that the where clause is what we use to filter records or filter our results. So it's used to extract only records that would fulfill or meet a specified condition that we state within the where clause or after the where clause. or multiple conditions in some cases. So I'm going to show you some examples from the very basics to slightly more complex that you can use. And these are the fundamentals that we're looking at right now. So where is really your sort of third fundamental after selecting the data, uh, extracting it from somewhere with your from clause, and then you've got your where clause. So this is fine. So let's look at how we actually go about this. So at the most basic level, let's say we just want to get the product ID that's equal to 1. Well, that's quite simple. We say where, then we need to state our column or a field. We can say where product ID here is equal to 1. Statement terminator, the semicolon, it's good practice to do that. You don't need to. Execute. There we go. So you can see that I get all of the product IDs that are equal to 1. However, really in the real world, it's not that valuable. You're rarely going to need to have to go into a whole large table within a large database potentially and take one record. Maybe if you're checking something very briefly, that would be beneficial. But there are lots of other ways to expand this that we will look at in due course. So we can actually just run this query again, the main body, by just highlighting the relevant elements. And that will mean that we can go ahead and look at this again. Or what you could do is just a double dash, which is a comment. So commenting a single line, and we could run it and that would return the same result. I'll leave that there because we're going to use the where, so we don't need to comment that out. Now, what happens if we want to maybe actually filter this by a name, a product name? So we'll say where name, and the reason you see that name in blue is because it's a reserved keyword. Ordinarily, you do not want to call your columns or name your columns the same way that reserved keywords present. So you wouldn't really use name. I don't know why it's been done in this way, given that it's a sample database from Microsoft, but hey ho, we could use an alias and rename this, or we could actually just change it when we look into creating tables. We can go down that sort of route if we wanted to. But anyway, for now, you'll notice that now we want to filter it with the where clause, but we're going to need to filter text. So before we could actually just state the number. However, when we're filtering by a string value or a text value, we need to include it in quotation marks. Here I'll do single quotation marks. Now, you see I've got a list of product names. Let's say we want to look at this bearing ball. So we can actually just type that in, where the name is equal to bearing ball, run that, and we get all the records that are equal to bearing ball. Now, it would be quite common that you would potentially have to go in, even though it's just one filter condition, you would have to go in and filter by product because there could be many results. So, for example, there's lots of flat washers. We will look later at sort of regular expressions where we could search by a pattern. Maybe we don't actually need this numeric value after. But in reality, there could be several cases that you would want to just search by one product name. Now that may be useful, like I said, searching on one product name or potentially ID or whatever that may be, because you could get a lot of records, but often you're going to have more than one filter condition because remember, we're really using SQL to take business logic and do things with it. So in reality, if you work in an automotive industry, you may want to view results by a few different car lines because they're manufactured in a certain way or a certain plant. Same with any sort of inventory location. So we'd likely have more than one filter condition. So what we can actually do is simply add and into the mix to add another condition. So and would mean that we need to meet both conditions. So we could have where name is equal to bearing ball, and we could potentially say and product number is equal to product number here, BA8327. And we'll click run. and that will return the result. Now, it's not so relevant here because, there's only one result with bearing ball, but often there could be, one product line, but it's got many different product numbers, or one product name with many different product numbers. So that would actually be incredibly useful. What I could do to show you again is we could put bearing ball. We can actually go into a cell here and just copy the value. So right click, left click to select it, and right click copy. And we'll paste the value in here just to show you how AND works. And now, if we're to run that, you'll see I put in a different product number, and AND isn't going to return a result because it needs to meet both conditions. Now, this product number was for blade, not bearing ball, so it's not going to return a result. However, if you want to return, you know, just you only need to meet one of the conditions, let's say, you could put OR. And then this is actually going to return both the results because we said where the name is equal to bearing ball, okay, or the product number is equal to blade. So in both of these rows, it's met one of the two conditions. So that will return the expected results. So that's important to bear in mind. Now, let's look at some other interesting features. You could actually use in here, and in essentially just allows us, the in operator, I will just quickly get our normal results back, to specify more than one condition within parentheses. So it's a lot simpler. It's what we might call syntactical sugar. It makes the way you write the code, the SQL code, more efficient. So we could say where name is in, which is, we're just going to list some names, bearing ball, blade, and we could say this LL. We will have to wrap quotations around here. LL crank arm. So check that spelling's okay, it looks like it. And now when we run these, we will get all the products that meet that name. So in is incredibly useful. And like I said, if you're thinking about this in a business context, you may have access to all of the databases. Someone in the business knows everything they want to see or get the results for, but they don't have the technical knowledge. So that would be quite a common situation. They may send you an Excel file with several different results, and it would be incredibly useful to just populate this within the in operator, within your parenthesis, and you'll get the relevant results very quickly. And this is one of the powerful things of SQL. You can get very, very, very fast results for even millions of rows of data, and sometimes billions, as the case may be, because the data is always growing in company databases. Now, I'll show you a few other interesting things. So let's go back and just query this bulk of data. Now, we saw the very basic example where we're looking at a single product number. So we could say where product ID is equal to 1. Execute there, add my statement terminator, my semicolon, and that's fine. Now, you don't want to have to put where product is ID. Maybe you have a sequence of numbers within a certain range. That's what you need to see. So we can actually, instead of adding an in operator or other methods, we could actually say where product ID between 1 and let's say 10, and we want to get all the results that could fall in there. Maybe that relates to a certain way of manufacturing things. And when we execute, we get all the relevant product IDs between 1 and 10. 1, 2, 3, 4. And potentially we put where the product ID is between 1 and 10,000. We will get all of these relevant results again. So that's really helpful. Or maybe we say where the product ID, do these two symbols together, the less than or greater than, and that actually means not equal to. So we'll get rid of the between, and this will mean when product ID is not equal to 1. And when we run that, you'll see we get every product ID but 1. we started 2. And that's incredibly useful again because in certain situations, the company may want a quick result just from the result of a SQL query, but they may want you to filter maybe one, say, product out or customer out because it's been discontinued. It may not have been updated in the database yet, it may be very fresh, but the company know not to include this in their analysis. So the last thing I'll show you is the sort of standard operators. So we could say where product ID is less than 50, and run that, and we get all these relevant results. And it's really interesting because traditionally you may think because it's a product ID you can't perform these mathematical operators on it, but you definitely can. So we could say where product ID is less than 500, for example. There we go. Or we could say where product ID is greater than 500 with the greater than symbol, with the right um, bracket here. There we are. Or we could say where the product ID is less than or equal to 500. So we include product ID 500 if there is one in our example, but there's not. So there's a huge range of ways to filter data, and we'll look into more complex examples potentially later on. But this is the third foundational pillar, and one that you should get very comfortable in because it's definitely a fundamental, and it's something that when you're working with SQL you will use, in most of your queries. So really important to get your head around this. Feel free to go away and play with some of these concepts, look at some of the operators that we've went through, figure out how this relates to some of the tables, and we'll go on from there once we have a really solid foundation. Now, order by is essentially the fourth pillar that we're going to look at in terms of SQL querying. So the order by clause. So if we take the select statement, we'll select all from, and this will be the way we extract the data from the specified table. We will say from production product. So this is our initial foundations or pillars, and we can then go ahead and say where the product ID is less than the ID, basically up to 500 or up to just below 500 there. So we have 3 pillars here. Select, we've got from, we got where. Now the fourth pillar that we're going to look at, this fundamental foundation, is called the order by clause. Now, essentially, we just use the order by clause to sort the result set, this output that we see within the results of our query. So when we use the select statement to query data from the table, we still don't guarantee the way that this is going to appear on our screen, the ordering of the values. So SQL Server can essentially just return a result set and there's no specified order available. So for us to explicitly guarantee the order of our rows or rows within our results output is to use the order by clause. And we can actually use the order by clause to not just sort the result of one column, we could sort a query result by multiple columns. So I'm also going to dive into how to do that. But first, it's worth looking at the syntax. So we could say order by, we'll need to select the column we want to order by. So maybe we want to look, as a simple example, just order by the product ID. Maybe that's the way that we want to look at our data because we're essentially shaping our data here with the where. We've got our filtering context there, our filter result. So now we want to look at order by to further shape this data or the perspective that we're going to view it in. So if we say order by product ID, let's see what happens. So you will see no change. Now that's because when we use order by and we don't specify an ascending or descending order, this is what happens. So SQL will automatically assume that we mean ascending. So you'll see the exact same result here, which means that it will result in the ascending order. So it'll start from the lowest and go to the highest value available. So we've limited the product ID to under 500. The nearest product ID we have to 500 is 497. So as you can see, the values flow from 1 right up to 497. Now, if we were, and you guessed it, DESC for descending is the exact opposite approach. So if I click execute, you'll see that example that was previously last in our result set is now first, 497. And there we go, all the way down to 1 at the bottom. Now, descending makes quite a lot of sense because quite often when you say we want to view a certain amount of values, maybe we've got products and the associated value to manufacture them or sell them, you would typically want to view the highest value first, essentially, especially in a sales context, because that's going to be the value that you potentially want to pay the most attention to in order to get some insights and figure out, look at some correlation or causation as to why that's performing particularly well. But as I said, we're not just limited to ordering by one column in ascending or descending order. First of all, what we could do is just sort a result set by multiple columns. Here's a nice example, a nice table to actually look at how we can sort by 2 different columns, which is quite an important thing to do, and I'll explain why here. So I've went to the person.state province table because this is good data because, well, it's not the most insightful, and typically we would use this to join, as we'll look at, onto other more transactional data. But right now, it allows us to see that we have a country region code. So CA you would assume is Canada, as the name associated is Alberta for the state province. And the US we have Alaska, Alabama, Arkansas. So, and so on. But let's look at how this could be done. So we'll ignore the where right now, the where clause. We don't need it to use order by, but we can start off by just saying order by, and for example, we could say the country region code. And that would make sense because the country region code is sort of the highest level of data, and quite often you might want to start there and drill down into your data in other ways. So if we say order by country region code, that's going to order everything in ascending order, this time not from 1 to a higher number, this will be alphabetically, so start with A. We can put ascending to be more explicit. I can show you if it was descending, we would again go down from the Virgin Islands and so on there. So, and Vermont in the US, because the country region code VI obviously is the furthest along in the alphabet. So what we'll do is we'll just be explicit. We'll say ascending, even though that's the default behavior. So we've ordered by the country region code in ascending order. Now we have a name. So let's say we want to order by name as well. Let's see what happens. So for this example, potentially we want to order the name section in descending order. So we will say name, descending order. Now what happens here? So the behavior changes of the ordering because it still orders by the country region code in ascending order. That can't be overridden by this name. But what happens is it means the name section, it's not as relevant here within American Samoa, but in Australia, the behavior changes because the name is now going in descending order. So for every item in Australia, it's descending order: Victoria, Tasmania, South Australia, Queensland, and it goes up. And then in Canada here, we have Yukon, Saskatchewan, Quebec, and we can see this is what we call partitioning. We're getting sections of data, and we can choose how we order that. So let's say I actually change this name column to be ordered in ascending order. Now previously, line 2 within Australia, that country region code isn't going to change because we've ordered it alphabetically in ascending order. It was line 2 was Victoria. Now let's see. If we change name also to ascending order, we'll see that now it changes. Victoria is the bottommost value within the Australia country region code. And the furthest is New South Wales. Now that's further on in the alphabet, but in this case, this is the highest alphabetical value that we have. So we're essentially able to order by one column, and within that ordering that we've specified, within each of these ordered sections or partitions of data, we then specify the ordering of the next column within the constraints of our initial order by statement. So hopefully that makes sense. And order by is really the fourth pillar that we would look at. There is some other things we could do. For example, we can actually order by an expression. So essentially wrap something in a function. So we could order by the length using len, which will just calculate the length in digits of the name field. And we could say ascending, highest to lowest. So order by length of name this time. So that will override anything that we previously specified with the country region code. And as you can see here, it orders from the highest number of characters held within this name section. So you can see the longest is at the top. It's completely rearranged the ordering. And as we move down, we have the small names. So AIN here, for example, just a few characters and the longest characters at the start. Likewise, if we were to specify this as ascending, so it counts digits, the number of characters, we'll see AIN is now the first result because we're going in the lowest to highest number of digits. We could just expand this and we can see that trend moving upwards. So that's quite a comprehensive look into order by. There are some other things we can do, but for now that's more of a beginner to intermediate in terms of the functionality of the order by, and that's the fourth pillar. So really important to be strong with the foundations because these are things that we just use, and as the complexity increases, we'll still rely on these. So yeah, you can do a lot with select, with from, with where, and with order by. So we looked at select, from, where, and order by in order to get a sort of general, to start shaping our data the way that we like. But there are much more ways that we can be specific here. And one of these is with the select top clause. So let me show you how this works and how and why we would use the select top clause. So initially, I will go back to our production.products table. So I will say select star, select all, from production.products, production.product there, and we will just leave it at that for now. So when we execute the results, we get a list of all the products or safety stock level. Now here you can see in the bottom, there's only 504 rows. If you wanted to further verify that, you could actually just say select count all, and that will, so you wrap the star in a count function, and that will count all of the available rows. And as we can see, it gives us 504 records. So that's correct. So in this case, selecting the top isn't the most sort of accurate real world use case. However, it is something that is very easy to demonstrate. So it's a good table to showcase this on anyway. So about the select top clause, essentially, we use this to return a specified number of results. So where you use the where clause for the filtering, that doesn't always guarantee you a certain proportion of numeric results. The select top clause is also useful because we can select a percentage of results to return. So the top 25%, maybe a common use case, 50%, maybe we want to view outliers, or we want to view sort of just segment our data into the top performers and the bottom performers in terms of our products, maybe, or our sales, or our stores, or our customers. They would all be very relevant use cases. Now, the other way that the select top clause is useful is because when you undoubtedly get to cases where there are data sets that are millions of rows, can really affect the performance if you select everything or if you filter by a very specific instance or by multiple instances. So select top can be a good way to either sample our data, just see what it generally looks like without waiting 5 minutes for a query to run, or it may be useful to actually return a specified amount of results when that's all that's required. So let's actually look at how this works. It's very simple. If I was to select, potentially I just want the top 5 results. TOP 5, and we leave the star and execute. And that will just return the top 5 results as standard. So we've got the product IDs. Very clear. Not the most useful way to do things. So let's look at maybe a more real world scenario. So we'll go back, select all. Now, an interesting feature that we may want to actually gain insights from in a business setting would be, like I said before, the safety stock level. It's incredibly important because it usually denotes the absolute minimum amount of stock you're allowed, and usually this is enforced by contracts with suppliers, customers, and so on. So what we can say here is we will just order by the safety stock level. And if you think about it, the way that you would typically want to see this displayed is in descending order, because you would really want to focus on the people with the highest safety stock, because that's where you'd have to be more careful uh, as to how often you're ordering that stock. Or as a data professional, you wouldn't, but people in the business would want to be very mindful of that, so you could supply them the data that they require. So if we order by safety stock level here, this column in descending order and execute, we now see that we have the product IDs with the highest required safety stock, and then it'll go to row 504 with the lowest, which is 4 pieces or 4 of each product ID. So that's good. But what if we want to be more specific? What if we potentially had 50 million products? Something similar to that. We could actually use top. So we could select top 100 potentially. Let's see how that looks. So we get all of the products with safety stock level 1000. Now we said we didn't necessarily need to be as specific as using the where clause to filter our results. So let's look at something else we could do. We could potentially select top 300, execute, and then that starts to give us a lot of safety stock level outside of the 1000 that we initially see, 1000 of each that we require to satisfy our minimum stock levels. Now, that's good. Potentially someone could just want to look at a certain amount of values, but where this becomes particularly useful is using this as a percent, because usually you would, if you're sampling data, you would want a certain percentage. So what we could say is select top 25% and the star just to denote of everything that we've specified. And as you can see, that gives us 126, which is 25% of our 504. And this allows us to view the safety stock level that's relative to that 25%. So you see 126 rows. Now this works perfectly across, other percentages. 10% gives us roughly 50 for that 504. Again, we can see we get the relevant products, and you can be as specific as you like here. Maybe you want 75%. Again, that would be quite a common value. We get 378 rows, all of the relevant safety stock levels. You can again be as specific as you like with columns, with ordering. You can integrate this with groups or where clauses. So there's no issue here. And it's a really powerful, I would suggest, either for performance, for saving yourself those long queries, or for sampling data, giving some data to a stakeholder, an end user, maybe from the business side, who just wants to sample how things are looking and the current state of affairs. So play around with select top, and particularly with that, the percentage and sort of displaying things by a certain percent. Now, one thing that commonly appears within any or a lot of SQL results would be the presence of null values. So that is essentially a field that has an absence of a value, therefore it's marked as null. So let me show you what I mean. If we say select all, and we'll go back into the production.product table. Now there is something that's nice to do here when you use SQL Server Management Studio, is actually instead of always having to type this out, it's even, we've got production, we can use IntelliSense and it will help us out a little bit there. It will give us product. We can actually simply take the table we're interested in, production.product, hold it and drag it over here, and we can query it. I'll just put the terminator at the end there for good practice to identify the end of this query that we're running, this process. And you can see here, anyway, within our result, we have a lot of null values. Now, one common business requirement would be potentially to have a list of results that don't contain nulls, and that's perfectly acceptable and a relevant thing to do, and one that is done very frequently. One good thing to do, although I'm going to show you this, if you've worked through Power BI, you saw that nulls can take place there and you can do things with Power Query. The ideal situation would be to sort it into another table within SQL or figure out a way to assign a value to those fields that don't have values. In another in a more ideal world, this could also be solved at source. So if you think about the architecture usually of data, it would flow from some sort of proprietary applications. So maybe a company has a stock system, they have a healthcare application, they could have lots of different things that they're using to capture information. Maybe, even a social media platform. It would then flow into something like a database system, so like SQL Server. It may be connected by things like Azure Data Factory, and then the information, when we're getting analytics for it, would flow into a tool like Power BI, Tableau, Click, Looker, whatever that may be. So this is a great place to correct null values if we can, or at least when we're querying data, we can get rid of them. So what we can do here is we can say select all from production.product, and we can use our where to filter information. But all we need to do now is go to the relevant column that we potentially want to remove null values from. So this could be color here, and we can say where color simply is not null. And our terminator there, and when we execute, we will see all of the color values that do not have null values present. So that's extremely useful, and it just shows you how simple it is to actually go ahead and start removing those null values. Very easy to go ahead and extend this as well to cover multiple columns. So we have colors not null, but potentially there's a requirement from the business or from a certain stakeholder to also have the size where nulls aren't present as well, because we have a lot here and that could potentially skew some of the data that we're trying to analyze. So we could say where color is not null and size is not null. Terminator there. Query. Move along. And you can see we now have 0 null values within our size. And we can extend that logic to more columns. So that's literally how simple it is. And as well as some of the other foundations and methods we look at, it's a really good way to get around a common issue that you will find in SQL, and in our case, more specifically in SQL Server. So give that a try, look at different combinations and multiple columns that you can combine and eradicate those null values. So one of the core things that we need to be proficient in is commenting our code within SQL. And it may not make much sense right now as we're still diving into fundamentals, but as our scripts become longer, we start to perform many different functionalities within one block of code. Comments become really, really, really fundamental. And there's a few reasons for that. Number one, we need to maintain the readability of our script. If it gets very long, it's helpful to segregate it with comments and explain exactly what we're doing. That will help collaboration with potentially other, colleagues, teammates. But this will also be fundamental if we go to review, fix, debug code in the future that we've been working on. because often we won't actually remember the logic behind what we were doing. So that's what's important. It's important to provide the why as to essentially the different functionality that we're using in SQL and why we're writing that code. There's also, we can sort of go about the how we're tackling these issues, but the why is important, and ensuring that readability for collaboration and ourselves is fundamental. So there's two ways, essentially, two core ways of commenting code in SQL Server. So the first one we've got is what we would call a multi-line comment or a block comment. So if I have the forward slash and the asterisk, and I close this off with an asterisk and a forward slash, and anything within these two symbols, I can go ahead and comment. So I could say, hello, my name is James. This is my SQL code to demonstrate comments. So anything within these two symbols, these two sets of symbols, is a block comment, multi-line. You could call it a multi-line comment. More popularly, you'll see a single line comment. So just could say this where clause filters active employees. If you tried to write again, that won't work because this just operates across a single line. So they're the two different ways to comment within SQL, and very important, fundamental to get your head around this and start implementing this as soon as possible. It's really good practice, and I can't tell you the amount of times I've went in to either develop on top of code that someone else has created or attempt to fix errors in their code, and it's very, very difficult to actually even make a start because you have no idea what their thought process was at the time. Then they may have left the company, or when you query them about it, they may not actually have any idea what they were doing at the time. So it's hugely, hugely important. Now, let me show you how this works in potentially a more sort of real world setting as per the data that we have here, the database, the AdventureWorks, in accordance with our sample data. So typically with a block comment, what we could do is introduce a script. So we could say this script was created on whatever date you want. So this could be whenever, it could be the 1st of the 1st, 2023. And we can say authored by James Andrew, and it could be this aims to provide the resulting to analyze. And we could say inventory trends, for example, something like that. And that would be typically how you may see a block comment formatted to introduce a topic, to give insight if it was a large script into the whole process. Single lines are more used to segregate code and to introduce maybe individual components within a whole script. So we've got, we'll just query some data. We'll say select all from production product. There we go. For now, some result here. There we go. 504 rows that we're used to seeing by now. So what we could do is we could start to introduce single line comments. So typically, you may see it a single line comment alongside code. So what we may call inline commenting in the same line as the code. So we could just say this is where the business manufacturing data is held. Just, as an idea, because we may have a database, but you wouldn't always have the pleasure of it being named like this, production.product within a production schema, and actually be so explicit. Sometimes it may have really bad naming conventions. You didn't author the database or the tables. You can't change that, so you can make life easier for yourself down the line. So we could also use single line comments like so above. So we could say this will form our core query for resulting insights later in the script. And again, you can see that starts to segregate things. So if we had, 200 lines of SQL, this would be really good for showing us a step-by-step account of how things were done. And then you could go in, you could use your standard where clause. You could say where, you could say color is not null. And then we could, again, add a single line comment here because it may not be actually clear as to why we can't have a null value. Because sometimes you may want to leave a null value in because it doesn't mean that, it just means there could have been an error somewhere in the process. Someone could have been inputting data into a source or company or proprietary app, and they may not have done something properly. The developers didn't keep things tight enough with their constraints, and it's just slipped through the net. We may still have to display it. But in this case, maybe we don't. Let's say inventory states null values or non-counting errors. So that's an insight into code, and that would be why commenting code, and that would be why it's so important. I hope I've managed to give you some actual context as to the why, not just the how, and really how you go ahead and use these in a proper manner, in a way that's going to be helpful. So, I mean, as we move forward, even if I'm not commenting out code, feel free to do that because that's just good practice. I may not because I've been doing it for a long time. And I know that when it comes to, writing actual code in a production environment, I'm going to do that. But I would encourage you to keep doing that just to make sure, get that muscle memory and really ingrain that process of commenting important and fundamental code. So our next step is quite a simpler one, but it's a good gateway into some of the more complex functionality that we're going to look at. And on this occasion, if you follow Power BI, we're really performing something we've done before, but within SQL, which is concatenating or joining different text values. However, in SQL, we obviously take this from a column or potentially a variable, which we'll look into later. But for now, we'd be looking at joining different columns together to make another column. And we typically do this with what we call string values or text values. So like, as usual, let me go in and actually show you how this would be done. So again, we can select all from, and we'll just drag in our production.product. Add our, go back there with Control Z there, and we will add our statement terminator. So when we execute here, we've got our product ID, name, number, and so on. We've already seen this. But for our use case, I'm actually just going to we want to look at the name and product number from now. So we'll say select name, and we'll look at the product number. Here we go. And we can execute now, and we get these two fields. Now, regarding string concatenation, there's actually a few different methods that we can use. So what I will do to make everything a bit more readable, I will drop the name down a line, product number down a line, and we're going to look at how we can join these two columns together to make one united column that has the product number and then the name. We join them together. So let's look at how we could do this without using any of SQL Server's inbuilt functions, and we'll look at that afterwards. But from the most basic perspective of joining columns together, we could do something like this. So we could take product number. So essentially we grab that column, that field. We use the addition operator to add together two different columns. And we could say name. We are going to refine this, but this would be the very, very basis. So now if we were to execute this query, we would get the product number and the name joined together. Now this isn't much use to anyone because There's no formatting. We've not separated it. We haven't specified a separator, so that could be a space, an underscore, a hyphen, however we want that to be, a full stop, a period. But we can refine this now. So what we will do is we will call this, let's say we'll just call it product code. Remember, we can alias a column or give it a name within our query results by either putting this product code, that's just a name I'm giving it, and equal to essentially the concatenation of columns that we're using. We could also, I will just Control X to cut that. We could also say as, and that would work too. We could say as product code, and when we refresh, we get that. But I'll press Control Z, remember that, to undo anything that we've done. So we now have undone those steps, we're back, and if I execute again, we get the product code is equal to this. But we still need to refine this further because we have the product number and the name, which makes up the product code. But we could actually say something like this. We could add, just because we're essentially adding another string value, we need to encapsulate it within single quotation marks. So we will say product code is equal to the product number, as we have here. We want to add a space before we join the name on. Not a space, sorry, a hyphen before we join the name on. So we'll execute, and that's starting to look a bit better. So we have the product code, and the product code is equal to product number with a dash or a hyphen and the name. And that forms together what we're looking for. But it's not necessarily the most efficient way to do this. There are a number of other ways that we could perform this. So first of all, we could use, if we were just looking for a straight concatenation, we could just use the concat function. Help if I spelled that correctly. The concat function within SQL Server. And then we could just say, we can specify what we actually want to join. So again, that could be the product number and a comma this time, and then the name. And we could go ahead joining these together. The issue is, again, whilst we've got the field name, the column header, the product code, we don't actually get the separator inbuilt into this. So there's actually another function we could use, concat underscore WS, which means concatenate the strings together, join them together with a separator. That's what the WS stands for. So there's a specified order that we need to put things in. So we can see when we open up this function, we first specify the separator, and then we expression and expression, all separated by commas to define the different steps. So we need to specify the separator and then essentially the columns or fields that we're going to join together. So we could specify our separator as our dash, as we previously did. The first field that we will require will be the product number. Number, we can find it here. And then we need to specify the name. And now here, there's everything that we require to do what we did the first time around, but in a much nicer format. Now, it's important to specify that this separator doesn't just have to be a dash. For example, if we leave a space in between our quotation marks, we would just get space. Or we could have a full stop or a period here to join it that way. But in most cases, this hyphen will make a really good separator. And yeah, essentially, you'll see this a lot where people potentially they'll reduce a string down to a code to create a product code if they don't have one within their system. This gets built into analysis and any follow-up from the business with tools like Excel and so on. So that's how we can actually build our own product codes or identifiers. And the concat underscore WS, concatenation with separator, is a really good function to do so. So I'd recommend, as usual, you give the different elements of joining together strings a try, see which one you prefer, and down the line, this will come in really handy because, again, this is another fundamental that you will use very regularly. And usually any text functions like joining string, separating parts of strings are something that you will use on a daily basis. We're going to look at some SQL Server string functions in more detail. I say SQL Server, most of these, if not all, are available across all levels of SQL, whether that's MySQL, Postgres, Oracle. They should be consistent. Like I said, SQL's complies to an international standard, so most of these functions can cross-pollinate and be used in other dialects of SQL. So what we'll do, we'll start off by just saying select all from, and we'll say production dot product. We can execute this. And what we're actually going to focus on, just for the sake of this sort of section, will likely be the product name and the product number, because a string function in SQL essentially takes a piece of text as an input, and we can perform different actions or functions to make it return an amended piece of text, essentially. So we'll look at how we can do this. So what we'll do, as the first example, we're actually going to look at the len function, which you may already be familiar with. So len returns a number of characters from a character string. So essentially, it's there to count the amount of characters within, it could be a column, so each value within a column. It could be a single value or a variable that we declare. But right now, we'll just focus on the column. So we could say select name and len, which is length function of name. We can see how this looks. So we get the name, and this will provide the amount of characters. We can say, we'll say, just call this name length as the column alias is equal to length, and the length of the name. We'll run this again, and we get the specific characters as per each name. We could go a step further here. We could actually order it by the length of the name column. We'll just place it in descending order so that we go highest to lowest, the longest names to the shortest. And there we go. That's how simple it is to use the length function. Now, the strength of a lot of these functions, and we'll look at this in an example later on in this tutorial here, where we'll look at substring. The strength of these string functions is they can really be used interchangeably with others. And when we get to that stage of writing longer SQL scripts, this will all start to make sense in terms of the sort of interchangeability and versatility of using these together. So now let's focus on the lower. And all the lower does is it converts a string to lowercase. So again, we will select the name column. We'll also just call this lowercase product name. And we can just say it's equal to lower. That's the function to turn everything to lowercase. Then again, from production dot product. Now when we run this, you can see we have the name here where we have capitalization here at the start of adjustable and race, and the lowercase just simply turns everything to lowercase. Now this can be useful if we're taking in certain string input. Maybe we're taking we can look at things later on like replicating tables or creating temp tables. We could take an unformatted string input and change it all to lowercase, or what we could actually do is change it to uppercase. Very simple. Instead of lower, we will just specify the upper function. That will do the same thing there, where we get everything in uppercase. Especially for shorter text or product codes, uppercase is particularly useful. Now, what we're going to do now is look at a slightly more complex example. And this is called substring, which is exceptionally popular and very usable, used very heavily, and we'll see why here. So first of all, what I'm actually going to do is I'm going to just demonstrate this in a less complex way with just an arbitrary value. We're not going to take anything from a column. So I'll just call this substring example, and I will set it equal. So we specify the substring function, and the substring, this essentially extracts a part of our text string within, a larger string from a specified value. So what we can say, substring example is equal to substring, and we need to specify some arguments. So I'll just supply some text. We won't use the column just yet. So I will say substring example, and then we can specify where we want this substring to actually start extracting the text from. So I'm going to say point 10, the 10th character index, and then I specify how long I want that to maintain for, where I want to cut off the end of the new substring, the new piece of text that we're taking from within the larger piece of text that we've supplied. In this case, we didn't reference a column, we just referenced the text value. So when I run this, we get example, because what happens, substring moves along to the 10th character, and it runs for 8 characters, and it leaves us with the text example. So let's actually look at this within a more complex example, where we'll actually take elements from the column. So first of all, we'll say select product number, and we're going to take this from the table that we've been working with. So to start off with, I will just specify an example here. So I'll say from production dot product, and just to limit the results, I'll say where product ID is less than 5. And what would happen here? We get the product number from production.product where product ID is less than 5. Now let's say we actually want to take a portion of this text. Now, one thing that we would encounter is it's not as simple sometimes with the substring as just specifying a specific starting point and an end point with a character count. Like we did, we had 8 as our last parameter, where we said, that's how long I want you to count for, and we'll extract everything there. Well, one of the issues is that in real world, these product numbers are quite dynamic. So for example, if we wanted to separate after this dash, this hyphen, there's a good chance that this wouldn't always be in this position here. Maybe there would be a product number where the first portion had 6 items, So we need to actually sometimes be a bit more careful with how we do this. So let me show you in a slightly more complex example how this could look. We could select the product number, and then we could go ahead and select, we'll just call this substring column example, and we'll set that equal to substring. And I'll go through this and then explain this, the logic afterwards as to how this is working. So we need to specify the product number as our first argument. This is where we specified just a text value in single quotation last time. We're actually just referencing the column now. And our starting point will be something called char index, which just specifies the index of a particular character. And we're going to point it towards the dash or the hyphen. And then we want this to pull from the product number column. And then what we'll say is we will specify +1 because we want this to start, the substring portion to start the next character after the dash. So the last sort of argument we'll have here, because last time we just had a single text value, a starting point and an ending point. We're still doing the same now, we're just using some other functions to show you how we can piece things together. So here I will do the length of product number, and I will subtract that from the car index here dash and product number. So before I explain how this is actually happening, let me just run this and show you. So what happens is we're actually able to successfully extract the numbers after the hyphen, but this would be more of a dynamic solution if we had a consistent sort of format. It wouldn't matter if there were lots more characters. It's a way to dynamically actually take a substring. So let me go over what's actually happening here. We take the product number, that's self-explanatory, standard column, and we then, this substring column example is using the substring function, which takes 3 arguments. The column that we want to pull it from, product number, that's fine. The second argument is the starting point. So we use car index to specify where the character that we want to start from. And car index is going to locate that based on the parameters we give it, which is this hyphen from the product number column. And we want it to start in the first character after this hyphen. And then our third argument, when we want this to stop, we specify that we want the car index where this hyphen is and the whole length of the product number string. So this would be the maximum length, and then we want to minus to where the hyphen is, and this will isolate just this section here. And that means that we get this dynamic substring. And then just standard, we take production.product and where product ID is less than 5. So that's a bit more of a complex example, but when you get more familiar with SQL, substrings are going to be very popular, and text and string functions are just something that always have to be done. You're regularly dealing with what we call dirty data, data that's not formatted or structured in the best way, and a lot of that is due to errors when inputting text. So what we can do now is we'll look at a couple more functions, or a few more functions. The first one I want to look at is write. So we could, and all that does is it extracts a given number of characters from the right, and we also have left, which just extracts a given number of characters from the left. So we'll say select product number, and then we will say from production.product, and we will add a new column here, and we'll just call this write example. Set that equal to write function, and we'll say product number and 4. What this does, it starts at the very right hand side of this product number, and it will pull 4 characters from the right hand side. And there we go. So we get 53881, 9108. This is again after the hyphen, but as you can see, in a solution where there were more hyphens or a different structure of formatting, that wouldn't be enough potentially for what we want to do. So we need to look at more dynamic methods, potentially something like we did before, utilizing substring and car index, len. There's another function called pat index for pattern indexing. So there's a lot of different options there. Again, we could change this to left example. Items from the left instead. And there we go, we would just have 4 from the left. So AR5, AR-5 instead of the other way around, where we were taking 4 characters starting from the right. This time it's just starting from the left. And the last function we'll look at is called replace, which again is very handy. So we've got the product number from production.product, and now we can use replace, and all this does is replaces all occurrences of a string or a portion of a substring within a string with another value that we specify. We're just replacing text essentially. So we'll just call this new product number, and we'll set this equal to place. product number. We will replace the hyphen, and here we could say with a full stop. So we've got three different sort of parameters or arguments. We have a new column called new product number, and we're just replacing this hyphen that we see in the product number with a full stop. And that's how simple it is. We can just replace a portion of text with another. Equally, we could replace it with any other piece of text or symbol. Here we've got a forward slash, and that will replace in the query. It's not going to change the existing table. It's not that permanent. There are other things that we can do that we'll look at later on if we do want to action that. But right now, it's just really helpful for changing some text and output, maybe formatting it, aligning it to the way that the business wants to see the insights that we provide. So there's some really handy text functions. As I say, text or string functions are something you're never going to get away from. They're essential. So get to grips with them. But more importantly, like we saw with the substring, I would start playing around with them and looking at how they can interact with each other for really powerful and dynamic solutions. They will drive huge value to businesses because the issue is at source, people are just careless with how they structure things and input things. So really get familiar with them. Structured Query Language, SQL, is a programming language and a large part of programming languages. And the initial reason for a lot of computation was the ability to perform mathematical operators. Obviously, in SQL, we're going to look at doing this with field values or columns, and I'll relate these to real-world scenarios or situations. But right now, I can just showcase, how easy it is to just do standard calculations in SQL. As long as we preface it with a select statement, we can then go ahead and do whatever we like. So we could do 50 multiplied by 5, for example, and we'll just alias it. So we could use adds this time for a change to alias it, and we'll just call this column name for the result. So when we execute that, we get 250. And obviously, it's it can be as specific as you like. It's programming language, so there's absolutely no issues with the computational power required for mathematical operations. And again, there's really no issue here. Now, I guess the complexity comes when you're trying to take business logic and translate that or that use of mathematical operators into SQL. So I'm going to show you some very real situations or scenarios as to how you could use this. So first of all, we need to reference a table. And at this point, it's important to note that if you do want to get rid of this results pane, there's a very quick way to do it in SQL Server. You can just press Control R, and that will toggle it on or off as you like. So just Control and R, that's it. Now we're going to use a slightly more transactional table. So what we would consider usually in a dimensional model would be a fact table, whereas your customers and your products, like we've looked at in Power BI, would be your dimensions. Your fact tables are largely going to be centered around things like sales or transactions. So we have sales.sales order details. So we'll look at that. First of all, we'll select all from sales.sales order detail. Statement terminator, and we can execute. So what's interesting to see, we have a lot of almost calculations performed already. So you can see that here we have a unit price and there's a unit price discount. This value is set up so that essentially this could be multiplied. It's a percentage to create the line total. So in the information or the system that came before this, that's what will be happening if there's a unit price discount. So that's important to note. So we're actually going to go ahead and look at replicating this. So we'll select it. You could just append a column on by selecting all, then creating our new column here, but we'll just get the relevant columns just so that it's nice and clear. So we'll take, for example, just product ID, and we will say unit price. Let's see if there's anything else that we may want to capture here. Product ID, and we'll need to actually get the correct spelling. That would be helpful. Unit price, we've got order quantity. Yeah, that should be all right for now, just to take these two fields. We will look at some other more complex examples in future blocks, but here we go. We've got our product ID and our unit price. So how can we take our knowledge now of mathematical operators that we've just went through? So standard would be things like multiplication, addition, subtraction, squaring numbers, whatever that may be, and actually take this into a real world scenario. Well, we may have a use case that in this certain month, potentially there's a January sale, on our products or our parts or whatever we're manufacturing in our inventory. So we could actually simply say everything with basically across the board is reduced by 20%. So how would we actually perform that with our use of mathematical operators and actually make something 20% reduced? Well, it's actually very simple. So if we assume that the unit price is 100% of what they would pay, if we multiply that by 0.80, that's going to give us 80% of the initial price, because naturally the unit price is a figure of 1 in this context. So to remove 20%, we would just multiply it by 0.8%. And if we execute this now, so we'll take product ID, we will include the original unit price for a comparison. And we'll take the unit price multiplied by 0.8, and when we execute that, we'll give this an alias as well. We'll say reduced January price is equal to unit price by 0.8. As usual, you could use the as keyword for the alias, but I prefer to lay it out this way, because if you were to then segregate things like we would in a more complex script, I find it much more readable to know the equals sort of prefaces what we're referencing. People find as easier, but to actually read the alias after what we're performing when it's a new calculation, I find that a bit jarring sometimes. So this is a helpful way to do it. So when we execute it, we can now see the unit price is equal to our sales, so 20% off. Our standard unit price is now equal to our January sales price. Now, what we could also do here, we could use another mathematical operator just to showcase what we can do. So we could say January price difference equal to, and what we'll say is unit price minus, and we'll look at things like CTEs later, but we can't just reference this new column because it's still getting executed inside the same query. So what we'll do, we'll just include the whole formula here. So January price difference is equal to unit price minus unit price times 0.8. So essentially that reduced January price. We'll look at how we can reference things like new column aliases in future blocks, but that's outside the scope of what I want to showcase here. So we have product ID, unit price. We've got a reduced January price here, or sale price, 20% off. And now we're calculating the difference between the two. So obviously we viewed a percentile or a percentage change, but it's going to be much more helpful for people to have actual figures. So we can now view the difference in prices between things. So we've knocked £404 off this product ID, or dollars, whatever that may be calculated in. And again, $4 here. So we can go and see, and we could then go into a further analysis and compare, potentially within our BI tool like Power BI, what's selling well, whether there's a correlation or causation between the huge reductions, or whether people prefer to pay less price with a smaller reduction, and so on. We can see how our January reduction would affect sales. So that's actually two examples of really commonly used real-world use cases that we would use mathematical operators for. So give this a try, look at some of the other things, maybe division, and play around with things. And yeah, again, hugely foundational. So we're only going to build on concepts like these. It's important to really nail them down, practice, explore some of the other tables, and really cement this knowledge. Previously, we went through the product ID, the unit price, and we just set a January reduction price across the board, where the unit price with the mathematical operator multiplication was assigned to 0.8, which gave us a 20% reduction, and we calculate the difference. Now that's fine, but it's not really that representative of a real-world solution. Usually we would have to apply a condition. So in layman's terms, essentially if we had a high value product, we may deduct more from the price than we would with a low value product. That would be, a general way to look at things. It doesn't always work out like that, but that's how we could think of it. So in that case, we're going to need to apply some sort of conditional logic to our SQL. Now we can actually do this with something called the case expression. And what the case expression does is it goes through conditions much like an if then else statement. In other languages like Python, we sort of looked in Power BI as well at if statements and the logic there. And it'll go through each condition. And if it evaluates to a certain condition, it will return a result that we specify. And if not, it will return another result that we specify. So we're able to provide conditions that help us to basically create a new column based on that conditional logic. So let me show you, first of all, the basic syntax, and then we'll go through some actual examples. So if I was just to say here, case expression syntax, and like I said earlier, get used to commenting. You can have your own style when commenting as long as you follow the two dashes for a single line comment, or the forward slash and the asterisk for a block comment or a multi-line comment. So here's the syntax for a case expression. Essentially, we start off with case, and we will say the case when, say, condition 1, then that's met, we provide result 1. Maybe there's a second condition. So again, we will say when condition 2 met, then result 2, and so on. And to finish this off, we would just typically say else, and we provide a standard result, so just a default result. And then we may just end, and we can actually end as to give the column alias. So we could just say conditional column. Doesn't really matter, but as long as we understand the syntax before we move on. So case when certain conditions met, SQL will loop through. And so if we say potentially, if an item is over a certain value, then either supply a text string or another value. Maybe we have a lower result for something that's of a lower value per product. We could do that. Or we could say anything else that doesn't meet our required value criteria, aka isn't a high enough price, then we can just supply a default result, or we can leave it as it is. We could just leave the standard unit price, and then we'll end as, and we'll name the column. So we're actually going to look at some practical examples now and cement this knowledge, because the case statement, like the other things that we've learned, or the case expression, is very common because you will often have to apply conditional logic to create new columns or virtual columns within our results. So let's go ahead and look at some actual examples. So previously we had the product ID, unit price from sales order detail. So we're just left with these two columns. Now that's great. And we said the aim here would be to go ahead and just look at how we could conditionally apply that discount. So let's go ahead and have a look. What we could actually say, we could take case when, and we could say, let's say the unit price, because we have number up in the 2000s, we've got quite a few that are quite high prices. So we could say case when unit price, because that's the column we want to take the values from. Unit price is, let's say, greater than or equal. So that covers anything that's 1250 and upwards. If it was greater than 1250, it would have to be 1251 and upwards. Then we'll say unit price. We will do that 20% off. We'll multiply it by 0.80 by 0.8%, which gives us a 20% reduction on a 100% value. But we're only going to apply that discount value to anything that's greater than or equal to 1250 in whatever currency. It could be dollars or pounds or euros and so on. And what we're going to do here, actually, because we need to we're just going to specify one condition, and then else is just a default value if we don't meet that result. Because remember, it loops through, it checks if the unit price is greater than or equal to 1250. If each cell is within our whole column, great, it'll apply that discount, but it needs to know what else to do if it can't meet that condition, because it's looping through this logic. So an interesting thing that we can do is just say else unit price. We just specify this original column, and quite intelligently, SQL will just provide the original unit price. So, we're just saying no discount if it's not greater than or equal to 1250, because it wouldn't be worth it from a sales perspective, let's say. And we just need to end as. So we could just end this as, let's call this qualified discount. So to review, we've got a product ID and unit price. Now we're introducing conditional logic because we don't want to give a blanket 20% discount. So if the unit price is greater than or equal to 1250, then the unit price is multiplied by 0.8, providing our 20% discount. If that condition isn't met, if the sales value isn't high enough, we'll simply just return the original unit price, and that means there's no discount applied. We'll end it by using the column name, and we're taking from the table sales.sales order detail. Now, if we run this query, we will see that we get the results that we expected. So for each product ID, if the unit price is greater than or equal to 1250, we get this nice 20% discount off our initial unit price. And we can validate that because roughly £400 is 20%, or 400 whatever currency, and we subtract that and we're left with around 1600. We can see that the lower values don't return an appropriate change because it didn't meet the criteria of greater than or equal to 1250, and so on. So that gives us a more realistic way, because typically when you're asked for something, there's usually some sort of business logic that ties in with some sort of condition. So it's really helpful to know and to practice case when. So you could introduce more than one condition, where you could say something like case when the unit price is potentially greater than or equal to 500, and unit price is less than 1000, then we give it a certain discount. So we could give it a 10% discount there, multiply it by 0.9. And we could actually introduce another case when statement. So we could just simply say, again, start again here. We just need when, because we've already specified our case. And we could say when unit price is greater than or equal to 1000, then unit price multiplied by 0.8. And then else, we just specify the standard unit price. So now we've got, if a value is greater than or equal to 500 and it's less than 1000, we provide a 10% discount. If it's greater than or equal to 1000, because it's a higher value, we'll give a 20% discount. Anything else that falls underneath the range of 500 simply just goes down to the standard unit price. No change there. So if we execute that, then we should see our results. So we can see where we've got a unit price of 2000. Here we clearly get that 20% reduction. Here we've got 809, and we see a 10% reduction here because that falls between 500 and 1000, and the lower value 5.70, zero discount. So that's perfect. That logic's working as we expected. So let's look at another use case where maybe we don't want to directly output a numeric value. Let's look at having a string value. So the logic is exactly the same. So I'll keep my case when, and I'll say case when the unit price is greater than 1250, then we can actually output a string that just says high value. And we can just end the next part with else low value, and we can just end as, we'll just call this value classification. So this is simpler in a way. So we've got case when unit price is greater than 1250, then we will say high value, else we will have low value, and then we will need to specify this is we'll need to get rid of the qualified discount here, and that will get rid of the error lines that you saw. So we've got product ID, unit price. If the case is over 1250, we output high value. Else, anything else that's under 1250 or equal to 1250, we can just supply low value. So the logic is going to work exactly the same, but when we execute this, you can see we now get a string value. Again, you could supply as many conditions as you like, but this is essentially, this is quite good because it provides us distinct groupings. So if we want to shape our data like this, this would be good for slicing our data, looking at which products are high or low value. Maybe you want to view this in an analytics tool, BI tool like Power BI later on. Maybe good for a pie chart, for segment analysis, for bar charts, whatever. So the string value also serves a real purpose, and sometimes people just want to view data in very clear classifications. So conditional logic is something that we will always want to use, and it's really well used within the case expression. There's several of these, and we will look at them in more of an isolated format. But as we move through this block of this course, we're actually going to look at piecing this together with other functions. So it will become more powerful. But it's important to gain a practical understanding of these core aggregation functions and what they actually can do and the power that they bring. So count displays the total number of values by column. So essentially, dependent on any conditions or where logic, filtering logic we give the query, it's just going to go through every line and iterate through and give us a numeric value as per how many lines they are. So that would make sense if we've got things like product numbers maybe, but we just want to calculate each line if they're all distinct to figure out how many products we actually have in our inventory. Because if we were to use something like sum, that would just that would add up all the product numbers, and that wouldn't make any sense. It wouldn't be relevant. So count simply just counts every line that's relevant to the conditions we gave it. Sum just takes all of the values in a column. So this would be sensible because our database with things like sales is very transactional. It's line by line. We often need to see an aggregated view, potentially in a total sales column or in a unit sales column. We just need to see how everything we've sold sums up, or we give a condition and we filter it by territory, we use a where clause, or by country, but we will still need to see a larger aggregated value, a sum of everything that we have in that column. Average works in a similar way in that we have our whole column values. Again, it could be the sales, and we just take the average. So how we would normally calculate an average, we take the sum of the column and we average it by the amount of instances that there are. Minimum displays the smallest value by column, and max displays the largest value by column. They're pretty self-explanatory in themselves. So without further ado, I will get going and show you just how this works practically. Again, we'll look at this in an isolated manner, which maybe isn't the most effective in the long term, but right now when we need to understand the fundamentals, it is. So again, we'll go back into select all from sales.sales order detail. We can execute that and we can look at the columns that we have available. So a good contender would be if we want to count all of the sales order IDs that we have, then we can go ahead and take account of, this would be a good column, the sales order ID. So we could say select count sales order ID, and this is going to return a single combined or scalar value. It's just going to be a single cell output. So we need to give this a column title essentially when we have the results. So we'll alias it like we have done before. So I'll just call this total orders here, and we'll set that equal to the count of the sales order ID column. So SQL will go through like this: 1, 2, 3, 4, 5, 6, and so on, and give us that total figure. So if we execute now, we see that we have 121,317 orders. So already very effective, and we will look later on at adding a lot more functionality and power here, but it gives us a nice summary value, and sometimes that's all stakeholders may want. So it saves us having to, go in, throw around data, pass around company data, or create visualizations in BI tools. Sometimes this is all that people need. So that gives us the count. However, what if we were to say count distinct sales order ID? What happens now? Our original figure was 121,317. We now have 31,465. So why is that happening? Why is that so much smaller? Well, if we go back and select all from sales.sales order detail, we can see here, these aren't unique values. So potentially in some situations, we might want to show the total sales by a sales order ID. So that would be the sum of the unit price by this column. Now it's not going to be effective to show this on a line by line basis with a standard count. It's not unique, and it's going to give us multiple values. So we can actually group this by the unique sales so that we get a true picture of how much each sales order ID brought in. So that's why we would use distinct to get unique values. Just important to remember the syntax. We have count on the outside of the parenthesis, and distinct actually falls within the inside next to the column that we actually want to calculate. In our case, it would be sales order ID. So let's look at some other of our aggregating functions. So we have, let's see, we have sum next. So sum is fairly straightforward. We would use this to calculate all of the values in a column. So a perfect contender for that would be unit price. So select sum of the unit price from sales order detail. And we can just highlight this to run this particular piece instead of commenting this out. And we see we get the sum. We'll give it an alias as well, just total sales, because this is associated with a sales order ID, so we can assume the unit price is actually a sale by each line item. So again, we'll run that. Total sales And later on, we'll look at how to format output. But yes, very, very large number, and that makes sense because it's going through every individual line item. Like I say, when we look at this later and we learn to group certain things together, because we can use aggregations with the group by statement, this will make more sense. But right now, it's we're providing more insight anyway than we've sort of previously seen. So again, we could say average sales is equal to the average. Now just remember, average, we can just type AVG for average, the average unit price here. We can see that the average sales per line item is 465, whatever the currency is, pounds or dollars, or even euros, whatever that may be. So that would be because we have a lot of instances where the value is very high. We've seen sales of sort of over 2,000, and we've also seen sales that sit around $28. So this is just taking the average spend of each instance. And it's obviously a really powerful function because averages are something that's a metric that's very commonly used when looking at business performance, especially within sales. So we can take the minimum now. So we can say min unit price, and we'll just say minimum sales. I find it very helpful when I'm writing my aliases just to be as descriptive as possible, because we can't guarantee that everyone, let's say that we share this detail with, eventually will know what min sales value means. So even just minimum, it just makes things a lot more explicit, and that's the way that I prefer to do things. So that's a piece of advice I could potentially pass on, because it just might save you some issues later. So if we execute, we see the minimum sales value by product we have is 1.33 rounded up. Now we can look at the maximum sales value. The max unit price, and we will just, so what, interestingly, if we just hit execute, that's going to run both of our statements together here. So we can see the maximum sales value that we have is apparently 3,578.27. Now we can actually go ahead and validate this in the first statement. So we can say select all from sales order detail, and we can say where. We can say max. Oh no, we don't even need to say max. We'll just say where unit price is equal to this value here. So we can just copy that cell, right click copy, and right click paste or control V. As it's a number, we don't need to wrap it in any sort of quotations. And we can just check, although we'll be very confident, it's good to validate that this number is present within our unit price, just to make sure nothing's gone wrong here. Not that it would, but we can see we have this sales order ID with the following unit price. So it was correct when it gave us this value as the maximum sales price. So that's the core aggregation functions. Also nice to show you a bit of validation, how you can take that, run different queries simultaneously to have different windows open if we want to perform a comparison. Remember, if we want to minimize this results window, press Control R to open or close it there. And yeah, we're going to build on these a lot. So get comfortable with aggregation functions. Make sure you understand what they all mean so that you're not lost later in the process when we begin to build up our Lego blocks, add a bit more functionality, complexity, but also what comes with that is a lot more insight. What I'd like to do here is put together some of the more complex topics we've been looking at, by no stretch of the imagination actually. Complex, but the gradually more complex topics. And we're going to piece some of them together and look at specifically how we can use the group by statement to actually take some of those aggregations we used before, so things like sum and count, and make them more powerful by giving them more of a grouped context. So let's see what I actually mean, and let's start with our first example. So I will select all from and we'll be using our sales order detail table here. I'll just run that, execute, and as we've seen before, we get our sales order ID, so each sale, we get a product ID, and we get a unit price. That's specifically what I'm really interested in here for this particular table. So first of all, let's take the product ID and the unit price potentially. So if we were to select product ID, and we'll take unit price. Again, we'll just copy and paste this here, the from section, and we execute that. This is what we get. Now, it's not really helpful to view this in such a regimented sort of transactional step because we don't actually get much insight here. So what we could do is, instead of having just these repeating product IDs, we could take this sum of this column, but we could actually apply it to each product ID so that we get a more insightful value as to how our products are performing, what's more popular, what sells well. So let's look at how we could do this. We've got the product ID already and the unit price. So actually all we need to do is sum this like we've done before. So I'll say total sale value is equal to, so we're just providing our column alias, the sum of the unit price. Now, if we were to go ahead and run this, we'll encounter a problem. And you'll probably see this error a lot as you're learning how sort of things work in a more intermediate sense. But we see sales.salesorder.detail.product ID, this column here, is invalid because it is not contained in either an aggregate function or the group by clause. Now, what it's actually saying here is when we choose to aggregate something like the sum of a unit price, well, that isn't going to work in the way that we viewed the data before, because we can't take the sum of a whole column and just assign it to each of those product IDs in a transactional fashion. So this is where group by comes in, and this is what we're going to look at now. So this is the syntax, group by. And all this is it just groups rows that have the same values into summary rows. So we could think of the summary rows as a product ID, as a customer, as a supplier, as a size or color, as a material, and so on. All these sort of more dimensional things. And the group by is usually used with aggregate functions. So like we looked at count, sum, average, min, max. To group that aggregated result set into more sort of relevant contexts. So let's look at what we actually mean and how we can bypass this error. So naturally, you may be confused about what you group by. Well, the area that you would group by is the column that is not within an aggregate function, because it wouldn't make sense to group by the column that we're sort of rolling up. It would make sense to group by this actual dimensional category. So the rule of thumb, basically, if you are ever confused, you want to group by the product that's not aggregated, or the column that's not aggregated. In our case, that's product ID. So now let's see what happens when we run this. Brilliant. So what we've actually got here is we've managed to take that previous aggregation, but that unit price, that sum, the total sale value, wasn't that helpful just as one scalar value. Now we're managing to make it more insightful because we're actually showing the sales by each product ID. So we've taken something here, a very transactional table, that doesn't actually provide us much insight if we want to look at this at a higher level. By using group by and aggregations, we've managed to shape it to something that looks like this, which is actually really helpful in a lot of ways. What we can do as well, we can use some of our prior knowledge and take order by, and we can just simply order this by the product ID, or you could order it by the total sale value if you wanted to view the highest value. But for me, it makes sense to view on a product ID level to order this, and we'll just say ascending. We'll go from the lowest product ID to the highest. We can execute that. And now we have something that's shaped really well, provides insights, and actually looks a lot more appealing because we've structured it in a more rigid way. So that's how we can use group by and aggregations to provide more insight into some of the high level metrics that we may have. But we've just grouped by one column. We can actually group by more than one column. So let's go look at another example in order to strengthen our knowledge on this topic. So what we can do is we can select all from, and this time we're going to take production dot product from our AdventureWorks database. And if you've taken part in the Power BI elements before this, the AdventureWorks, we're using the same data set. It was just imported in slightly different ways. So these things should start to look familiar, and be thinking about how you can take some of these concepts that we're learning here and potentially build it into Power BI for practice. And I'll start to relate these things as we move on as well, and where's specifically relevant in each tool. So we've got select all from production.product. Again, we'll just execute this, look at the data that we have available. So what I'm specifically interested in is I'm going to show you a slightly different way to aggregate things. And every item is essentially a unique product ID, those 504 rows. So potentially I want to look at the amount of product IDs per color, and maybe even we can break that down further by size. So let's look at how we can do this. So what I could do is select, we'll say color in the first instance, and we could say, I can simply, because I know that each row is a unique value, I can simply say count all, because it's just going to count all the rows and bring it into the context or the grouping of color. Control C to copy this from production.product, Control V to paste it. So let's look at what happens here. I will just alias this again with, I'll call this product count. Set that equal to the count of all rows. Let's see what happens here. So remember, a nice pointer. If you don't group this, you're going to get the same error. And it's something that you will, like I said before, likely come across a lot of times. So you need to remember to group it. You also need to remember which column you're grouping by. And remember, the rule of thumb, it would be the column that is not being aggregated, because that's the context that we want to view things in. So group by color. And we will spell that correctly, group by color. And now what happens when we run this? We can execute. Now, we get the color. We do have nulls present. Potentially, we don't want to see null values. You know, sometimes it is useful because there could have just been a mistake somewhere and we still need to see those represented. We would need to dig into this further. In this case, let's say the basic logic permits that we don't need to worry about null values. Well, how would you eradicate this? So previously, we would have written something like where color is not null. And what happens if we run this? We can see we get an incorrect syntax near the word where. Now, why is that happening? Well, when you group things, you can no longer use the where filter context. So in the occasion that we're using group by, we need to use something called having, which is essentially the replacement that we use to filter things when we've grouped objects. And now, saying having color is not null, we get the result in a much nicer format without null values present. So how could we maybe make this a bit more powerful? Well, maybe we could also group this by the size that we saw. So we could simply add size in. Product count is fine. And we've got color, we've got size, we need to specify a comma here, and we will also group by size. Now what's going to happen here if we do this? We're also eradicating the nulls. Now we've got the color, and what happens here is for every color, we get every size and the product count. And you can see black is repeated here. With size 38, we have 5. Black is repeated here, size 42, 5. Black is repeated here, size 46. We've got 2 products. So we can actually filter in or group by groups within groups, which would mean that there's other examples you could have. Maybe you have a customer and you want to group further by city within that customer and maybe view sales. So you could do that with the 2 standard columns and aggregated, sales at a sum value. Now, what we can do here as well, we could also say and size is not null. And there we go, we can execute and we get a much nicer format. Size 38 black, we've got 5. Size 40 black, 4. Silver 38, we've got 5 products. Color silver, size 40, 4 products, and so on. So the grouping is really powerful, and it's something, again, we'll build on. So there's a few things that you should remember here. When you want to group by, typically you want to group by the column or columns that are not being aggregated. Otherwise, you'll get that error. You do not want to use where when you group. That will provide an error. In this case, when we've grouped objects, we can filter by using having. And we can also get rid of the nulls in the same way as we did before, is not null, while specifying having. That doesn't change. That works with where and having. I guess the last thing that I wanted to show you while we're in SQL Server Management Studio here, there'll be a lot of occasions where you maybe want to save this, go back, review it when you've got more knowledge, practice things. So you can actually just go in here, File, you can click Save Query As. So for us, I can just, you can place it wherever you want, and you could within your file explorer, and you can just call it, say, we'll just call this group by demo, and that should be good enough for now for me to remember. It gets saved as a SQL file, so you can save it into your system. You'll see it now gets saved here. You can delete it as you please, and when you want to import it again, you can open a file. So you go into the menu, like any Windows menu, File, Open. We'll give you the option for a file, and we see here we have Group by Demo. Open it up and make sure we're in the right database. Remember, I'm in master, so I want to get to AdventureWorks 2019. I could also change that by typing use AdventureWorks 2019, and I can execute the query exactly as before. Both my options there, or I can just execute this second query that we've carefully shaped with our knowledge. Everything is present. So that's a good tip. You'll likely want to save things as you go along. So there you go. Feel free to practice, get used to overcoming some of those errors and some of the slight changes like using having. Combining things that we've sort of pieced together, we've been able to gradually increase the complexity. So that's looked like from the basics of querying with our select statement, we then moved on to things like aggregations and then looked at how we can group these to get good insights. Well, with that in mind, I'm going to take you over a very important fundamental within SQL known as subqueries or subquerying. Now, subqueries are going to allow us to, again, on our journey, gradually power up that insights while adding a little bit of a learning curve. But this is going to almost let us unlock the next level and really drive forward how impactful the queries that we return and the data that we retrieve actually is. So SQL Server subqueries, they're sometimes known as nested queries or inner queries because it's essentially a query within a query. And I'm going to show you practical examples as to what that actually means and what it achieves. So essentially, subqueries very powerful. Um, they're very flexible, which sometimes means through that, because they're quite flexible and versatile, they can be hard to learn at first. But we'll look at trying to get around this slowly. And again, in later tutorials, we will we'll build on some of these concepts and piece it together. So they allow us essentially to combine data or to combine tables in some cases, or even correlate certain sets of data to others to get a result. So potentially we might want to look at the average of the sum of all sales by product ID. Previously, we looked at the sum of all sales by product ID, but it would be harder to get the unified average of the sales by product ID if we didn't use a subquery or an inner query or a nested query, however you want to phrase it. And subqueries, we can use it within the select statement, within even things that we're going to look at like insert, update, or delete. And they either display a single, what I've referred to before as you may hear as a scalar value, or a table value. And a table value could just be likened to the result, the table result, the query result that you get when we actually go ahead and query our data. So we're going to look at some practical examples now. And what we want to look at first is how we can use a subquery within the where clause of a select statement to find the sales orders that are greater than the average unit price. So how would we actually go about structuring this to find our high performing sales orders, products, and actually go ahead, analyze this and look at some of the, take some action and look at the depth of the data here. So the first thing that we need to do is we need to have a relevant table, which is sales.sales order detail. So I can select all from sales.sales order detail and execute. And like we've seen before, this gives us our unit price field that we're interested in. This gives us our sales order ID that we're also interested in. But what we can actually do, first of all, we can just start with the select all. We're just going to view all the tables where the unit price is higher than the average unit price from this same table. Now that sounds very complex as to how you would go about structuring this, but once we go over the syntax of subqueries, it should unlock a new way of thinking in SQL. So let's go ahead. So I'm going to say where, and I will sort of lay this out and structure it so it's easier to read, where the unit price, because that's this column here we're wanting to look at, and we'll be using one of our operators, which is the greater than. This right pointed bracket is greater than, so it's greater than a certain value. And now we need to say where we need to select all of this table values, all the columns and rows from this table where the unit price here is greater than the average unit price from this table. So it's worth noting that we've got 121,000 rows here. So let's look at how this changes as well when we execute it. So we'll say where the unit price is greater than, we need a set of parentheses. That's how we sort of distinguish our subquery or inner query. We will just say select average unit price from sales dot sales order detail. There we go. And we just need to, finally, we've got select all from sales.sales order detail where we need to fix that. The column name unit price, that's why there was an error, is greater than selecting the average unit price from sales.sales order detail. So when we execute this, let's look at what happens. Originally, we have 121,000 rows. And we can execute, and we now have 36,000 rows. So what this is doing is it goes ahead, first of all, and it runs, and this is why you could call a subquery an inner query. It runs this inner portion within the parenthesis. So essentially does this. It takes the average unit price, which turns out to be 465, and then it says, all right, now we need to select everything from this table where the unit price is greater than 465. So the inner subquery is run first, and then the outer query is run. The remaining block of code that is almost wrapped around this subquery is executed. So if we were to run this all together, we would expect our results in unit price to be greater than 465. And we can see that. We have 2,000, 800, 700, 2000, 818, 2000, and so on. So that's already really valuable because we've gone beyond sort of grouping aggregates and shaping our data to having advanced um, where or filter conditions based on subqueries. So let's actually go ahead and look at another type of subquery. So this time we're going to say maybe we want to find the average of the sum of all sales by product ID. But to do this, we're not actually going to use a where clause. We can actually take our subquery and use it in many different areas. We could use this within the initial columns that we list, or in our case, we're going to use it within the from clause at the very end of our query. So like I said, we want to find the average of the sum of all sales by product ID. So what we need to do first is actually find the sum of all sales by product ID. And then we take the outer query, wrap it around the subquery or inner query, and we will get a result. So we actually looked at how we could get the sum of all sales by product ID before, and we wrote this out. So we'll do it again. So we'll say select, I'll get rid of the results by pressing Control R, select product ID, and we'll say total product sales, because we're writing an alias here, is equal to the sum of unit price from sales.sales order detail. And remember, because we've got an aggregate function here, the sum, we actually need to group this. So we're going to group it by the column, like we said, that isn't aggregated. So we'll say group by product ID. There we go. Now, if we run this section, just to give you an initial picture like we did before, we have our product ID and the total product sales, the sum there. So what we want to do now is we actually want to find the average of this query that we've calculated, the average of the total product sales sum. So it's actually quite simple to do this. We have our inner query, what we will execute first, and now we just need to wrap it around, or I say the SQL engine will execute this first. We can write the whole query with the nested subquery within it and execute all together. So I will call this average sales. So we'll say select, we'll need to alias this, average sales, and we'll say is equal to the average of total product sales, because you'll notice that we reference this as total product sales. As we're not running it in one sort of just simple query, we can actually reference the column alias, whereas if we just ran a simple block of code, we would need to reference the sum of unit price. So we can actually reference the name here, which is quite handy. So we'll say total product sales, we want the average of this figure. Now, how do we actually make this all tie up together? Well, we need to use from. Say from, a parenthesis, wrap it round here, and you'll notice there's still an issue. So when we actually go ahead and use the subquery within from, it's helpful just to alias it at the end. So I will just put average sales, AVS there, alias it, and now everything looks like it's going to work. So let's execute and see what happens. So this, whereas the first time we got a table value, or a table value returned from our subquery, just the standard sort of query output you would expect. This one just returns a single value, and a scalar value can be helpful in a lot of different situations when we just need some summary figures very quickly. So what happens here? We select the total sales by the product ID like we did before, and we group it together and get that initial shape. That's done beforehand by the SQL engine. And the second part of its calculation, it then selects the average of that figure, of the total product sales by the product ID. And that's how we get it. So subqueries are really versatile. There's a lot more ways that you can use this. We'll likely touch upon this in the subsequent sections, and it really is more of an intermediate or advanced concept, but it's the perfect place to sort of show you at this stage how we're almost adding different blocks together. Like I say, Lego blocks, the analogy, we've went from sort of the basics of querying to aggregations, which adds a bit more complexity, to grouping those aggregations by a certain context. And now we're looking at actually using subqueries to power up the insights that we're able to gain even further. So feel free to practice this, get used to different use cases, explore different scenarios, and really strengthen your knowledge around subqueries. Previously, we've looked predominantly at querying data. So that would come under what we call DQL, because there's sort of subgroups of the different types of operations we perform within SQL. And DQL stands for Data Query Language, and that's things predominantly like your select statements. Basically, statements that are used for performing queries on the data within schema objects. This then allows us to extract the data from the relevant database and perform our operations and our queries on that specific data. And that's fundamental. A lot of the work you would do as an analyst would be surrounded by querying data and getting it into a shape and into other tools in a performant way. So that's very relevant. Before we close out this sort of fundamentals block, I just wanted to go over something else that's called DDL. So that'd be Data Definition Language. And this is predominantly focused around creating our own tables and databases and so on. So although you may not initially be doing this sort of work, in the future you may have to develop schemas as part of an analysis role, and schemas would be the sort of table design. Maybe you're transporting data from one place to another, and that would be essential to be able to define a table and understand how we build them, which is why I want to showcase it now. So you'll notice that we've been working out of this AdventureWorks 2019 database. We also have the master database, which sort of governs everything within sort of the top root database within our SQL Server. But what we can do now is actually we're going to create a table and insert some data into a table, writing T-SQL, so SQL Code, Transact SQL, Microsoft's proprietary SQL flavor. So what we'll do now is we'll actually just create a new database to house this new table in, because traditionally we wouldn't want to combine it with the AdventureWorks because that focuses on cycle manufacturing data, where we're going to look at just sort of testing out how we create things. So what we will do is just say create database. I'm just going to call this test because that exactly pretty much sums up what we're doing. We're testing out the syntax and the code required to create tables. So to create database, it's just create database is the syntax, and then you specify the name of the database that you want to create. You can make it whatever you like. I'm just going to call it test. We'll click execute, and we'll see commands completed successfully, and it tells you the completion time. So I can go ahead here, refresh the Object Explorer, and go back into databases, and we'll see that we have the test database available. Now, it's worth noting that there are ways to sort of right-click, create new databases and tables within SQL Server Management Studio. Within the GUI, you see new database, but we're actually going to focus on doing this with T-SQL, with our SQL code, so that it gives you more practice of writing SQL, and this deeper knowledge will really help you with other concepts that we'll come across. So we now have our test database that refreshed quickly, and it's available. So what we're going to do here is use our DDL command, Data Definition Language, to create a table. Now, we're just going to base this on sort of very loose on employee data. Once you see how I do this, you can go ahead and potentially look at how you want to maybe structure your table, create any other columns, and test your knowledge there. So what we will do is the syntax, like creating a database, to create a table is just create table. And then we need to provide a name for our table. So I'm just going to call this employees. And I will open up the parenthesis there. What I'm also going to do is ensure that I'm in the right database. So I will just say use test, just to ensure I'm in the right place. And I'll just run this so that you'll see it change in the GUI there. to test. There we go. So I know that I'm essentially putting my table in the right database, in the right location. So I've called my table employees. Now I've got to devise some columns. The first one that I'm going to add to my database is just employee ID. And all we need to do now is specify the data type. So for employee ID, that would typically be 1, 2, 3, 4, and so on until you maybe have thousands. So that's just an integer. That's a whole number, and we would use int and a comma to denote that we're moving on to the next column. You could put primary key here if you want. We'll look at that side of things later. That's more into sort of indexing and performance and really out with creating a table schema in the basic format. The next thing we're going to do is we'll call this first name. And typically, when we have a name, we would go down the data type route of either varchar or nvarchar. Essentially just allows us to specify a number of characters. Basically, text is what we would look to include here. Because I would typically use nvarchar, but it's SQL Server Microsoft's proprietary data type. So we'll just use varchar, which means if you do move into another type of SQL, such as MySQL, you've also got the know-how that this will cross-pollinate and work across both systems. And normally what people do, you may see this varchar 255. But a key thing about SQL is we want to try, in order to make everything perform well and run quickly, we want to specify the storage amount that we allow. We don't need to specify 255 bytes because this loosely basically says that we'll accept a first name up to 255 characters. Now, we're not going to find a first name with 255 characters. We could specify 10. My name James would fit there. But again, we're probably, when we try and insert some data, some will fail because there will be many first names that are over 10 characters. So in order to give me leeway, I'm just going to put 100 because I don't know, there may be an error when someone inputs data. They may input the wrong thing. I don't necessarily want my data to fail being imported into my table. And 100 characters is not going to do much for performance. It's not going to provide really any sort of performance hit or negative impact there. So then the next column that I will place in will be last name. And that will also be varchar. And I will specify 100. You don't actually need to specify. I believe if you don't specify the number of bytes, we just default to that 255. But sometimes it's good just to be explicit, and it's a good habit to get into when we do really need to consider the performance and the storage cost of things. And I don't mean storage cost in a monetary sense. I mean the cost to our performance, our running times, our capacity, and so on. I will also put the department. Again, that will be a varchar, just varied characters here, and 100. And lastly, I'm actually going to put active, which basically we're trying to denote whether they're an active employee or not. And I'm going to use a data type you may not have come across, which is bit, which is just a Boolean value. If you were in the Power BI and Power Query, we see true or false values. Bit is a very important value because you'll see it in a lot of different things like employee status, whether we're manufacturing products, and it's just a 0 or a 1, where 0 means false and 1 means true. So if an employee had a active bit value of 0, it would mean they're no longer in the company. That's false. If they had an active bit value of 1, it would mean true. They work for the company. And that's actually all we need to do to create our sample table. So let's look at the syntax again. We need to specify that we're creating a table, the name of the table, and with each column name, we need to specify a data type. And these are very common data types. Integer for a whole number. We would have decimal if it wasn't a whole number, if it was something like currency or a floating point number, something like maybe instead of 1, it would be 1.15. We would need to specify decimal. First name, last name, department, all can go within this varchar, which is sort of a bucket data type largely for text. And active is bit, which is a Boolean value. 0 or 1 to mark false or true. And our terminator, and we should be able to go ahead now and actually just create our table. So if we run this and click execute, we get commands completed successfully. So let's see how that looks in our database. We expand test and tables. We can now see we have the table, dbo.employees, and as standard it gets the dbo schema, which is just standard database object. We don't need to worry about that. But I'll say select all from dbo.employees. When we do that, you'll see we get the column names, employee, ID, first name, last name, department, and active. But rightfully, we don't get any data because we haven't inserted any data in yet. That's a separate action. So let's see how we can do that now. So we can say insert into, which is the syntax required to insert data into a table. Insert into. We then need to specify the table. So that would be employees. And then we need to specify the columns that we're going to insert data into. So you could leave this blank, providing that we were inserting data into every field or every column, but it's better to just be explicit here. So we'll say insert into employees. We want to insert into all of these columns. So we'll say employee ID. We will choose first name, last name, department, and that will cover all of our columns. And now what we need to do that we've got this, we need to say we're inserting in values. So we'll say values, we're inserting into the employees table the following values. So for example, we'll have our parenthesis here again, and our employee ID for the first row could be 1. The first name could be Joe, it's a string data type or text. The last name blogs, Joe blogs. Department could be human resources. And the active status 1, true, they're active. Now, that's fine. We could actually go ahead and add this data into our table. But you might be wondering, okay, well, how do I insert multiple rows at a time? Simple. We can actually just place a comma and we go into our next line. So we can actually just copy and paste this and modify it. So we've got values. Again, we may not actually need that comma there. Let's see, we'll keep the comma there, values, and we'll just change things up a little bit. So it'll be employee name, employee ID 2. We will say Josephine blogs. They will be in the sales department. And they will have an active value of 0 bit value, which means essentially they're displaying a false. So that means they're no longer in the company. So let's see, we've got insert into employees, and we got values there. And we can actually go ahead here and now this should work. So we've modified everything that we copied over. We're inserting into the employees table the following values against these columns, the whole range: employee ID, first name, last name, department, and active. We could just insert one row. So employee ID 1, first name Joe, last name blogs, department human resources, and a bit value of 1, which means they're active. And then we have a comma to insert in a second line of values. So that's employee ID 2, first name Josephine, last name blogs, department sales, and they're not active, so they get a 0 value there. So let's go ahead and insert this. We'll execute, and we see 2 rows affected. So that basically means we've inserted 2 rows of values, and it should work Well, now let's go ahead and actually check. We'll say select all from employees. Now run this. And there we go. We've got employee ID 1, Joe Blogs, Human Resources, active 1. Employee ID 2, first name Josephine, last name Blogs, department sales, and no longer active. Now that's great, but let's assume that we've actually, I'll move this down, we've actually incorrectly entered someone's name. Well, how would we go ahead and update that and modify it? So let's assume employee 1 is actually James Blogs, not Joe Blogs. Well, how would we update that value? So we can actually just say update. We can use this command. And we'll say, we will update the table employees. And we will set the first name equal to James. Now the issue here is it may be difficult to set the first name because we haven't given it a credential, so it doesn't know where to assign that first name. So we can simply use our where clause, say where employee ID is equal to 1. SQL now knows where to go ahead and target that first name change. In here, we've used the syntax update, we've provided the table. Set just means we're going to change the value. So first name is equal to James from Joe, where the employee ID equals 1, and we can go ahead and do that. So let's run that command and execute. One row is affected. Press Ctrl R to get rid of that. Select all from employees. And there we go. First name is now James Blogs from Human Resources, is an active employee. And we've got Josephine Blogs, is an ex-employee in the sales department. So that's how simple it is to go ahead with SQL code, create your own table and insert some values. This may not be something you do too much in the future, but it's really important to have a grasp on this. Not only will it help more of our intermediate and advanced SQL components and knowledge, it may be something that you eventually have to do. I've had to do it in a lot of software when I'm building data pipelines and things like Azure Data Factory. It's helped me in Power BI when I need to create new schemas in SQL to bring it into Power BI to be more performant. But in the real business world, you may not have to create your own tables because the data will already be coming from somewhere like a proprietary app. But you will probably have to create a schema like this in order to get it in the right format. So this would be a good contender to go into your file bar and save and play with this. And we can then go ahead and if you like later on, you can practice and get a bit better with these concepts. And it will now be available within your test database also here within your Object Explorer. So have fun building things and trying that out. And again, cement that knowledge and build it into the muscle memory. And this will be a great skill that you sort of have in your data toolkit.